Have you ever stood in front of a door and said, "You can't go through here"? Physics thought the same thing for years. But in the dark depths of the universe, a miracle smaller than an atom has been quietly overturning all the rules for years. Quantum tunneling. Think about it. A particle standing in front of a completely closed wall. It's impossible to pass through. But it appears on the other side of the wall in an instant, defying classical physics. What if the same thing applies not just to atoms, but to galaxies, lives, and even destinies? Perhaps everything we've ever deemed impossible is actually hidden on the other side of a passageway we haven't yet discovered. Today, we'll talk about how this strange phenomenon, which turns reality upside down and opens secret doors to parallel universes, could be the invisible key to our lives. And remember, everything you know right now may just be the wall of the old world. If you're brave enough, get ready to discover what lies beyond that wall with this video. By the way, liking and subscribing to my video is the most effective way to support me. I would love to read in the comments where in the world you are watching from and what time it is. 1. What is quantum tunneling and why did it revolutionize the world of science? Quantum tunneling is considered one of the most extraordinary discoveries in modern science, a phenomenon that fundamentally shakes the basic laws of physics. According to classical physics, if an object encounters an obstacle, it must have more energy than the obstacle to overcome it. However, in the quantum world, things don't work that way. An electron or particle can suddenly appear on the other side of an obstacle even if it doesn't have enough energy to overcome it. This phenomenon, first theorized and then experimentally demonstrated by scientists, has changed our perception of reality. This is because tunneling is a mechanism that makes the impossible possible and is poised to rewrite nearly all of the rules of the universe as we know it today. To understand the impact of this phenomenon on the scientific world, it is first necessary to understand that tunneling is based on the principle of probability waves. In quantum mechanics, the location and energy of a particle are not definite, but are expressed in terms of probability. In other words, where a particle will be at a given moment is explained by a distribution of probabilities, which is very different from the certainty of classical physics. This is why it is mathematically possible for a particle to suddenly appear where it should not be. And this is where tunneling comes into play. It shows that not everything is certain, and that there is room for a little magic in the universe. The revolutionary nature of quantum tunneling does not end here. This phenomenon is not merely a theoretical curiosity, but also lies at the foundation of technological breakthroughs. From the sun's energy production to computer chips, from biology to chemistry, quantum tunneling operates like an invisible engine. Without tunneling, life as we know it would not even exist. From fusion reactions in the sun to the jumping of electrons between atoms, the most fundamental processes of the universe are governed by this rule. Today, thanks to the understanding provided by quantum tunneling, the doors to the subatomic world are opening wider than ever before. As scientists continue to trace this strange phenomenon, they have begun to wonder what other secrets may be hidden in the depths of the universe. Tunneling has not only opened the door to new technologies, it has also prompted us to ask bold questions about what is truly possible in the universe. We now know that the boundaries of reality are much more flexible than we once thought. 2. How can a particle pass through an insurmountable obstacle and reach the other side? In the classical world, if a marble cannot roll over a high hill, it can never reach the other side. But in the quantum world, things are completely different. If a particle faces a high-energy barrier and theoretically lacks the energy to overcome it, quantum mechanics offers an even stranger possibility. The particle can suddenly appear on the other side of the barrier. This is akin to a marble suddenly emerging from an underground tunnel and appearing at an unexpected point. The key word here is probability. Even when a particle is in front of an obstacle, its wave function leaks into the obstacle and even to the other side. Physically, the probability of the particle actually being beyond the obstacle is greater than zero. Therefore, at any moment, an electron or proton can pass through the energy barrier, violating classical rules and reaching the other side. In the quantum world, the door of possibilities is always ajar and never completely closed. When this phenomenon was observed in the real world, it completely baffled scientists. This was because it dealt a major blow to the universality and certainty of the laws of physics. The ability of particles to overcome classical barriers shook the very foundations of reality. Tunneling did not remain an abstract theory. It was repeatedly proven in laboratory experiments. From the behavior of electrons in semiconductors to the decay of radioactive materials, tunneling could be clearly observed in many processes. Understanding this phenomenon gave rise to new questions in science. Are there other insurmountable barriers in the universe that we actually can overcome? Will it one day be possible for particles to overcome barriers in the macroscopic world? The answers to these questions are still uncertain, but the fundamental truth revealed by quantum tunneling is this: the deepest laws of the universe are full of surprises that go far beyond our everyday experience. 3. What is possible that in a world where the rules of classical physics do not apply? Quantum mechanics offers us a world beyond the limits of classical physics, a world we cannot even imagine. While Newton's laws work perfectly in the macroscopic world, at the subatomic scale, strange phenomena emerge that invalidate everything we know. Particles can be in two places at once. Causality breaks down, and nothing is certain. In this universe ruled by probability, phenomena such as tunneling become normal. Here, even the meaning of time, space, and energy changes. Because knowing where an electron is does not mean you can determine its speed with certainty. Concepts such as quantum uncertainty and tunneling show that the fundamental fabric of the universe is much more soft and fluid than we thought. The either-or dilemma is now a thing of the past. Everything can be both and. This is a huge paradigm shift for scientific thought. In such a world, many possibilities that once seemed beyond the bounds of imagination are becoming reality. Matter and energy are in constant interaction, and waves of probability overlap one another. Tunneling, superposition, entanglement, and other phenomena whisper that the universe is actually a sea of possibilities. Boundaries and rules are no longer absolute. The universe itself is flexible, variable, and often surprising. This new understanding is paving the way for revolutions in technology and science. Quantum computers are pushing the limits of information processing speed thanks to tunneling. Teleportation is becoming practically possible through entanglement. Things that the classical world deemed impossible may be real in the quantum world, and this opens the doors to a whole new universe for humanity. 4. Why does the sun shine thanks to tunneling? The energy source of the sun and other stars is nuclear fusion reactions that take place in their cores. However, according to classical physics, it is nearly impossible for these reactions to begin because protons repel each other, and the energy barrier between them is immense. This is where quantum tunneling comes into play and sheds light on the secrets of the universe's greatest source of light. Thanks to tunneling, protons can pass through each other in an instant without overcoming the energy barrier, and fusion occurs. This is a miracle that would never be expected in the classical world. In other words, the hydrogen nuclei in our sun merge thanks to the probability provided by quantum tunneling and release an enormous amount of energy. Without tunneling, our sun would not be as bright as it is today. In fact, it would not even exist. This reality gives us a different perspective on the source of life. At the core of life on Earth lies this invisible magic that takes place in the depths of space. The continuity of nuclear reactions in the sun demonstrates how quantum tunneling can have enormous effects in the universe. In other words, even at the heart of the largest stars, the surprising rules of the quantum world prevail. This information is reshaping modern astronomy and physics. Tunneling plays a decisive role, not only on a small scale, but also in massive stars and galaxies. When we look to the sky to understand the origins of life, we are actually peering into the secrets of the subatomic world. This shows that the greatest miracles of the universe are hidden in the smallest scales. 5. Without tunneling, could life have formed? Quantum tunneling plays a critical role not only in stars, but also in the formation of living beings and the continuation of life. If this phenomenon did not exist, the transfer of energy and information between the most fundamental building blocks of the universe would largely cease. The impossibility of energy production in the sun would make life on Earth impossible. In other words, tunneling acts as the engine of existence. At the molecular level, many biological processes are also dependent on quantum effects. From DNA replication to intercellular signaling, traces of tunneling can be found in the maintenance of life. Some of the most efficient energy conversions in nature, such as photosynthesis, rely on the fast and efficient energy transfer provided by tunneling. Without these tricky paths of the quantum world, most systems in nature would never have achieved their current efficiency. The chemistry of life is also closely related to quantum tunneling. Some chemical reactions involve energy barriers that are too high to be overcome by classical means. Tunneling enables atoms and molecules to overcome these obstacles, making the formation of new molecules possible. This demonstrates that tunneling plays an indispensable role in the construction of the complex structure of life. Every trace of life we have today is actually the result of small miracles of quantum tunneling. Without this phenomenon, our universe might be a dark, cold, and motionless place. Thanks to tunneling, life is possible and continues to exist, both in the sky and on Earth. 6. What is the connection between quantum tunneling and parallel universe theories? Quantum tunneling is not only revolutionary in the subatomic world, but also offers a key to understanding the deepest secrets of the universe for theoretical physicists. When the idea of parallel universes became one of the cornerstones of the multiverse theory, scientists began to wonder whether quantum tunneling could make the transition between these universes more than just a fantasy. This is because in the quantum world, a particle can follow multiple possible paths at the same time and produce different results in different universes. Thanks to tunneling, it is theoretically possible for a particle to choose a path that is impossible in its own universe and find a new path for itself in an alternative reality. This connection becomes even more intriguing when combined with Everett's many worlds interpretation. According to this interpretation, every quantum event causes multiple possible copies of the universe to exist, and tunneling allows a particle to find a door between these copies. Some physicists suggest that tunneling could one day pave the way for inter-universe communication on a macro scale. If tunneling truly enables the transfer of matter or information between different universes, it would demonstrate that our universe is not unique, and that we live in a cosmos with infinite alternatives. There is no experimental evidence for such claims yet. However, mathematical models suggesting that quantum tunneling could open the door to inter-universal travel have sparked excitement in the scientific community. Imagine a particle is following a different path in another reality at the same time as you, and sometimes a short circuit occurs between these two paths through tunneling. This would be a revolution that would change our perception of reality forever. That is why the relationship between quantum tunneling and parallel universes has become one of the most interesting, most debated, and most confusing topics in modern science. If the traces of this transition are ever observed experimentally, everything we know about the universe will be consigned to history, and a whole new era of science will begin. 7. Are real wormholes possible? Beyond being one of the most popular themes in science fiction films, wormholes have become structures that are genuinely discussed in theoretical physics. Defined by Einstein and Rosen's Einstein-Rosen bridge model, wormholes are thought of as shortcuts connecting two different regions of space-time. But do such structures really exist, or are they merely a mathematical exercise? Whether quantum tunneling could play a role here is a major subject of curiosity. Theoretically, for a wormhole to form, space-time must be bent in such a way that the distance between 2 points is shortened, creating a kind of cosmic tunnel. However, this requires immense energy and negative mass. It is precisely at this point that the principle of quantum tunneling, which makes the impossible possible, comes into play. Just as a particle can overcome a barrier it could never pass through in the classical world, there may be unknown forms of tunneling that allow wormhole-like passages to open on the vast scales of the universe. To date, no wormholes have been observed. However, in the extremely dense regions around black holes, space-time may be unraveling in the same way as in quantum tunneling. Some theorists claim that mechanisms similar to tunneling were at work during the birth of the universe or at the heart of black holes. In other words, to open the door to a real wormhole, we may have no choice but to unlock the secrets of quantum tunneling. Perhaps in the future, when humanity learns the deep laws of tunneling, interstellar travel will cease to be a fantasy. While such ideas that push the boundaries of science may seem crazy today, it is important to remember that quantum tunneling has repeatedly shown us that the impossible can become possible. And this keeps alive our hope of encountering real wormholes in the future. 8. Are quantum tunneling and wormholes the same thing? Although quantum tunneling and wormholes appear similar at first glance, they are fundamentally different phenomena. Quantum tunneling is the ability of subatomic particles to overcome energy barriers through probability. A wormhole, on the other hand, is a cosmic tunnel that connects two separate points by bending space-time on a massive scale. In other words, one occurs in the microscopic world and the other in the macroscopic world. Nevertheless, there is a striking similarity between the two that challenges the imagination. Both enable the overcoming of seemingly impassable barriers. In quantum tunneling, an electron suddenly appears on the other side of the barrier, while in a wormhole, the two ends of space-time come together. Some theoretical physicists believe that quantum tunneling at the microscale demonstrates that similar processes may be possible in the large-scale structures of the universe. Some even claim that every wormhole is essentially a massive quantum tunnel. The fundamental difference between these two phenomena lies in their scale and physical mechanisms. Quantum tunneling arises directly from the behavior of particles, while wormholes occur in the geometry of space-time. However, both share the common feature of revealing that the boundaries we perceive in the universe are actually transcended. This is why considering tunneling and wormholes together could be a key to unlocking the secrets of the universe. There is no definitive answer today. However, as science advances, we are getting closer to finding the answer to the question of where these two worlds truly meet. Perhaps one day, when new forms of quantum tunneling are discovered, we will have concrete evidence of the reality of wormholes. 9. How do electrons ignore invisible walls? Electrons exhibit behavior that challenges the very foundations of reality by suddenly appearing behind obstacles that they should never be able to pass through in classical physics. How is it that these particles can seemingly disappear and pass through an energy barrier that is definitely there? This is one of the most fascinating aspects of quantum mechanics. Electrons do not simply move like small balls. They also exhibit wave-like properties. When they approach an energy barrier, their wave functions seep into the barrier and leave a faint possibility of existence on the other side. So an electron does not have to stop in front of the barrier in the classical sense, because when defined as a wave, it leaves a shadow behind the barrier. Thanks to probabilities, it sometimes suddenly appears beyond the barrier. This behavior is so strange and irregular that we can never observe it in our daily lives. Scientists have directly observed electrons tunneling through barriers in laboratories. In scanning tunneling microscopes, electrons pass through metal surfaces and provide us with images at the atomic level. In other words, this phenomenon of ignoring invisible walls is not science fiction, but today's scientific reality. This property of quantum tunneling shows how relative and surmountable the boundaries and obstacles in the universe actually are. Electrons prove to us that the building blocks of the universe are surprisingly flexible and cannot be explained by classical logic. And this continues to be a mystery that fascinates scientists. 10. How does tunneling play a role in the energy production of stars? Nuclear fusion reactions inside the Sun and other stars are the fundamental source of life and energy in the universe. However, these reactions cannot be initiated within the limits permitted by classical physics, as the electrical repulsive force between nuclei requires extremely high temperatures for them to merge. This is where quantum tunneling comes into play and releases the energy at the heart of stars. Thanks to tunneling, protons pass through obstacles that they cannot overcome classically as they approach each other. In other words, hydrogen nuclei fuse together by tunneling through the gravitational barrier, releasing enormous amounts of energy. Behind the Sun's constant release of millions of megatons of energy every second lies this invisible quantum game. Without tunneling, fusion reactions in stars would be much slower or would not occur at all. The universe would be a dark and lifeless place. This reality has revolutionized scientists' understanding of the origin of life and the formation of elements in the universe. The processes occurring inside stars are a direct result of quantum tunneling. The sun's light and heat are the fundamental forces that sustain life on our planet. Therefore, tunneling lies at the very center of the universe's energy cycle. Today, when scientists calculate the age of the sun, the abundance of elements, and the future of the universe, they must account for the hidden role of tunneling at the core of all these phenomena. Quantum tunneling is the reason for the existence of stars and, consequently, life. Everything from the brightest star in the sky to the smallest organism on Earth owes its existence to this invisible mechanism. 11. How did scientists conduct experiments on tunneling? The existence of quantum tunneling has been proven not only theoretically, but also experimentally many times. Since the beginning of the 20th century, physicists have studied the behavior of electrons in semiconductors and vacuum tubes and encountered results that could not be explained by classical physics. In particular, the invention of the scanning tunneling microscope enabled the direct observation of this phenomenon. In this microscope, a sharp metal needle is brought very close to a surface, and an electric current is observed despite the presence of a gap between the two metals. Classical physics claimed that such a current was impossible. However, thanks to quantum tunneling, electrons were able to tunnel through the barrier and pass to the other side. Experiments also demonstrated how the probability of tunneling changes by varying the thickness and height of the barrier. Thus, tunneling evolved from an abstract concept into a measurable phenomenon. Natural processes such as radioactive decay also demonstrate the existence of tunneling. According to classical physics, the escape of alpha particles from the nucleus is impossible. However, tunneling allows this escape. In laboratory experiments, tunneling speeds were measured in different materials and at different temperatures. The results were in perfect agreement with the predictions of quantum theory. Thanks to these experiments, the reality of quantum tunneling has been proven beyond doubt. Scientists today are advancing in technological breakthroughs and understanding the secrets of nature in light of these experiments. The direct measurement and observation of tunneling in a laboratory setting makes it one of the most solidly founded discoveries in the history of physics. 12. What is the difference between tunneling and classical randomness? The concept of randomness is one of the biggest differences between classical physics and quantum mechanics. In the classical world, even if an event appears to be random, we can actually predict the outcome with certainty if we have enough information. For example, which side of a die will land can be calculated in advance with sufficient data. However, in the quantum world, randomness is a fundamental law of nature and cannot be eliminated. In quantum tunneling, whether a particle will cross an energy barrier depends entirely on probabilities. In other words, even if two electrons approach the same barrier under the same conditions, one may pass, while the other does not, because the only thing that determines the outcome is the randomness at the heart of the universe. This implies a non-deterministic reality, which physicists believe is the essence of nature. Thanks to tunneling, the absolute certainty of classical physics gives way to the uncertainty of the quantum world. This distinction is revolutionary in terms of technology and scientific thought. Quantum computers owe their vastly superior speed and power to this principle of randomness. Scientists are pushing the boundaries of randomness to develop new information's processing techniques. However, this also means that some outcomes in the universe can never be fully predicted, as the underlying reality of tunneling and quantum events is a true, unalterable randomness. In conclusion, tunneling and quantum randomness construct a reality based on probability, uncertainty, and freedom rather than certainty at the deepest level of nature. This feature of the universe is both fascinating and thought-provoking because we live in a reality that can never be fully controlled. 13. What does tunneling say about whether there is really such a thing as coincidence in the universe? The classical understanding of science, which believes that everything in the universe has a cause and that coincidence is actually a result of a lack of information, has been dealt a major blow by quantum tunneling. This phenomenon shows that, at the most fundamental level, events can indeed be causeless and completely random. In other words, there are no hidden variables or invisible laws determining whether a particle will tunnel through a barrier or not. There are only probabilities and pure chance. This has caused a major shift in the philosophy of science. The statement, "every event has a cause," no longer holds true in the subatomic world. In tunneling events, two particles can produce different results under exactly the same conditions. At the fundamental level of the universe, randomness and chance have emerged as genuine laws of nature. In other words, sometimes things in the universe truly happen without cause. This situation has enabled modern physics to ask much more intriguing questions. If chance lies at the heart of the universe, how reliable is reality itself? Even if our knowledge and observational limits are infinite, we are still within a reality where we can never know certain things in advance. The window opened by tunneling has fundamentally transformed the worlds of science and philosophy. Quantum tunneling reveals that chance and uncertainty in the universe are not merely an illusion, but the very laws of nature. This new reality points to the existence of a much deeper mechanism of randomness operating at the core of the universe, beyond the world we experience every day. 14. Why are computers affected by quantum tunneling? Traditional computer technologies have become faster and more efficient every year, with the continuous miniaturization of transistors and microchips. However, in this race toward miniaturization, technology has encountered a limit: quantum tunneling. As transistors approach atomic scale, electrons begin to produce leakage currents through quantum tunneling rather than following classical paths. This fundamentally altered the operating principle of processors. Pathways that were once considered closed are now open due to tunneling, leading to increased data loss or error rates. Engineers faced the challenge of overcoming the limiting effects of quantum tunneling as they sought to further shrink circuit components. While tunneling paved the way for future quantum computers, it also became a barrier hindering the miniaturization of classical computers. This effect triggered a major transformation in the computing industry. Scientists and engineers had to develop new materials and designs to reduce the undesirable effects of tunneling. On the other hand, however, the fundamental logic of quantum computers was also built through the skillful use of tunneling technology. In other words, tunneling became both a limitation and an opportunity that opened the door to a new era. Thanks to quantum tunneling, it has become much clearer what will determine the limits of computer technology in the future. Without understanding the rules of the subatomic world, it is now impossible to build the super-fast and ultra-small computers of the future. Tunneling is writing the new rules of the digital revolution. What were the first applications of tunneling in modern technology? With the discovery of quantum tunneling, scientists began to explore its practical applications. One of the first and most prominent applications was the scanning tunneling microscope. This device revolutionized nanotechnology by enabling the imaging of surfaces at the atomic level. By allowing electrons to tunnel through barriers and move from one surface to another, scientists could now see individual atoms and even manipulate their positions. Another striking application emerged in semiconductor technology. As transistors became smaller, quantum tunneling caused unwanted currents, leading engineers to develop entirely new approaches to device design. These microchips, which form the foundation of modern computers and cell phones, became possible through the understanding and control of quantum tunneling. Another area where tunneling is used is quantum cryptography and information security. By leveraging the randomness and uncertainty properties of tunneling in information transmission, communication protocols that are far more secure than classical methods have been developed. The advantages offered by quantum tunneling are particularly significant in banking and military communications. Today and in the future, new technologies developed thanks to quantum tunneling are poised to revolutionize not only the fields of computing and communication, but also a wide range of areas, from medicine to space research. Tunneling pushes the boundaries of technology while reigniting humanity's imagination every day. 16. How does tunneling become a problem as transistors get smaller? Transistors, the driving force of the technological age, are the building blocks of information, processing, and storage, with billions of them found on a single chip today. However, as transistors shrink to the nanometer scale, quantum tunneling comes into play as an invisible leak. This leakage causes unwanted electrical currents to flow when transistors are either on or off. This effect leads to increased heat generation in processors, higher error rates, and reduced energy efficiency. In other words, as computer chips become smaller and faster, classical logic circuits become increasingly unreliable due to tunneling. Since electrons can tunnel through a path that should be closed, the accuracy of digital signals is compromised. As a result, chip manufacturers are working on new semiconductor materials, alternative transistor architectures, and three-dimensional circuit structures to mitigate the harmful effects of tunneling. Some companies have begun developing processors based entirely on quantum logic, abandoning classical electronics. In other words, tunneling has opened the door to a new era in technology. In conclusion, the limitations imposed by tunneling signal the end of an era and the beginning of a brand new technological age. The future of information processing technology is no longer shaped by the rules of classical physics, but by those of the quantum world. 17. Is tunneling at the core of radioactivity? Radioactivity is known as one of nature's most powerful and sometimes most destructive phenomena. However, the secret behind the disintegration of an atomic nucleus and the emission of energy and particles lies once again in quantum tunneling. In particular, alpha decay cannot be explained by classical physics because the energy barrier that the alpha particle must overcome to exit the nucleus is extremely high. This is where tunneling comes into play, allowing the alpha particle to escape the nucleus in a way that is impossible in the classical sense. This possibility is entirely explained by quantum mechanical laws and is one of the clearest examples of tunneling observed in real life. The lifespans and decay rates of radioactive materials are determined by the probability of tunneling. This phenomenon forms the basis of many technological applications, from nuclear energy production to radiotherapy used in medicine. In other words, tunneling plays an indispensable role not only in nature, but also in technologies that directly affect human life. Controlling and understanding radioactivity has been made possible thanks to tunneling. Therefore, when we talk about radioactivity, we cannot ignore the immense power and effect of quantum tunneling at work in the background. Without tunneling, none of the radioactive elements would decay, and there would be no heavy elements or energy flow in the universe. 18. What is the relationship between alpha decay and tunneling? Alpha decay is the event in which 2 protons and 2 neutrons, i.e. an alpha particle, inside an atomic nucleus are ejected from the nucleus. According to classical physics, extremely high energy is required for this particle to leave the nucleus, and this is practically impossible. However, quantum tunneling comes into play here. The alpha particle tunnels through the energy barrier surrounding the nucleus and suddenly escapes. This process is completely random and based on probability. Millions of alpha particles exist in a nucleus under the same conditions, but only some of them tunnel and leave the nucleus. This randomness determines the half-life of radioactive materials. In other words, how long it takes for an element to decay by half depends on how often tunneling occurs. Alpha decay is also used in nuclear energy production and some medical applications. Thanks to the mathematical model of tunneling, physicists can predict the radioactive properties of different elements in advance. This opens the door to many important applications in nature and technology. The fact that quantum tunneling is at the heart of one of nature's most fundamental energy transformations shows how universal and critical this phenomenon is. Tunneling works like an invisible key that can find its way out even from inside an atomic nucleus. 19. Why is quantum tunneling not visible on a macroscopic scale? Why does quantum tunneling, which is commonplace in the subatomic world, not appear in our daily lives? Because in the macroscopic world, i.e., at our scale, the wave functions of particles are effective over extremely short distances, and the probability of tunneling for large objects is practically zero. In other words, for a human or a soccer ball to tunnel through a wall, it would take a time longer than the age of the universe. This huge gap between quantum mechanics and classical physics stems from the fact that the wave function's propagation distance is inversely proportional to the particle's mass. Tunneling is common and easy for light and small particles like electrons. However, a soccer ball is made up of trillions of atoms and has a very large mass. Therefore, the wave function almost collapses, and the probability of tunneling becomes zero. Scientists are attempting to observe tunneling-like behavior in macroscopic objects by creating ultra-cold environments and special conditions. However, so far, the results have been limited to a few atoms or molecules. In other words, the extraordinary wonders of tunneling are currently confined to the subatomic world. Nevertheless, with the advancement of quantum technologies in the future, the possibility of macroscopic tunneling may be reconsidered. For now, as we move larger in the universe, classical rules prevail, and tunneling remains a magical rule of the microscopic world. 20. Schrödinger's cat experiment demonstrates how strange tunneling can be. Schrödinger's cat thought experiment was designed to show how distant and strange quantum tunneling and quantum uncertainty are from everyday life. In the experiment, there's a cat, a radioactive atom, and a poisonous mechanism inside a box. If the atom tunnels and decays, the mechanism activates and the cat dies. If tunneling does not occur, the cat survives. You can never know whether the cat is alive or dead without opening the box, because at the quantum level, both possibilities exist simultaneously. This experiment demonstrates that tunneling is not limited to subatomic particles, but can also carry over to the macroscopic world, because the tunneling of the radioactive atom is linked to a macroscopic outcome, the cat's life or death. This is where the quantum world's most bizarre encounter with everyday reality takes place. The experiment also questions the quantum principle known as the observer effect. The cat's state is not determined until the box is opened, because the probability of tunneling remains in a superposition state until it collapses with observation. In a sense, reality only becomes clear at the moment we observe it. Schrödinger's cat remains one of the most famous metaphors for how extraordinary tunneling is and how it transcends our conventional ways of thinking, continuing to astonish scientists and philosophers alike. 21. Why does tunneling challenge classical physics? The real reason quantum tunneling challenges classical physics lies in the fact that the laws governing nature and reality are much more flexible and uncertain than we thought. In classical physics, the motion, energy, and obstacles of an object are clearly defined. It is impossible for a ball to pass through a wall. However, quantum tunneling shatters this certainty, demonstrating that a particle can suddenly appear on the other side of a barrier it cannot possibly cross, and do so instantly and without any apparent logical reason. This is a serious challenge to the most fundamental rules of the universe, as nothing is now entirely predictable or certain. The phenomenon of tunneling overturns not only what we know about energy and matter, but also the concepts of causality and reality. The classical world is absolutely bound to cause and effect relationships. But in the quantum world, there is no absolute answer to the question, why? Why did a particle tunnel? Why did it pass to the other side? Why does it sometimes not pass? All these questions can only be answered in terms of probability. It is at this point that tunneling becomes one of the rare natural phenomena that radically questions the dogmas and absolute rules of science. This phenomenon clearly demonstrates the inadequacy of classical physics, not only intellectually, but also experimentally. Countless experiments conducted in modern laboratories have proven the existence of a quantum logic beyond classical laws. Phenomena such as particles passing through barriers, chemical reactions beginning, and even the sun shining cannot be explained within the framework of classical physics. That is why tunneling is so astonishing that it would never be seen in Newton's universe. Thanks to tunneling, we now know that the fundamental fabric of the universe is not as rigid and definite as we thought. There's always room for uncertainty, probability, and even miracles. This phenomenon, which pushes the boundaries of classical physics, has fundamentally changed humanity's view of reality and ushered physics into a new era. 22. Is there anything in our daily lives that resembles tunneling? Although it is not possible to observe a phenomenon exactly like quantum tunneling in our daily lives, some events can give us a glimpse of its abstract reflection. For example, the unexpected overcoming of obstacles we once deemed impossible can serve as a metaphor for tunneling in our subconscious. Tunneling reminds us that what appears impossible may actually be possible in a different dimension or perspective. Another analogy is water seeping through tiny cracks in rock, or a plant breaking through asphalt to reach the surface. Although these are not directly quantum tunneling, they are symbolic examples of nature overcoming certain classical obstacles through invisible means. In human behavior, this can be thought of as the emergence of our intuitions or sudden inspirations without knowing where they come from, or the overcoming of obstacles that cannot be perceived by everyday consciousness. In electrical circuits and microchips, tunneling actually affects our daily lives. The technologies used in our cell phones, computers, and internet infrastructure process and store data thanks to electron tunneling. In other words, we encounter the practical effects of tunneling every day, but we cannot observe the exact same thing at the macroscopic level. Ultimately, although quantum tunneling cannot be observed directly, examples of overcoming obstacles in nature symbolically show that nothing in life is certain and that there may always be an invisible path or a hidden solution. Tunneling underscores that possibilities and surprises never end, both in nature and in human life. 23. Can particles be in two places at the same time? One of the greatest mysteries of quantum mechanics is that a particle can exist in two, or even many more places at the same time. This is known as superposition, a concept so bizarre that it cannot be explained by classical logic. An electron, while orbiting an atomic nucleus, can actually be in all possible orbits at the same time. Only when observed does it behave as if it chooses a location and is caught at a specific point. The most famous example of this phenomenon is the double-slit experiment. An electron behaves as if it can pass through two slits at the same time, creating interference patterns. It seems as though it has passed through both slits at the same time, or even existed in two places at once. Tunneling is also a result of this superposition, because there is a possibility that the particle is in front of, inside, and behind the obstacle. This strangeness may seem like a situation that has no counterpart in the macroscopic world. However, at the subatomic level, the fact that particles can be everywhere and nowhere shows that reality is not rigid and absolute. The quantum world is based on probabilities and potentials. As long as we do not observe, anything is possible. Therefore, the fact that a particle can be in two places at the same time is an indication of the soft reality of the quantum world. This proves that reality, at the smallest building blocks of the universe, is dynamic and flexible, far beyond our intuition. Reality is much more interesting and surprising than we think. What is the fine line between quantum tunneling and superposition? Although quantum tunneling and superposition are two of the strangest and most striking phenomena in the subatomic world, there's a fundamental difference between them. Superposition refers to the ability of a particle to exist in multiple states or locations at the same time. Tunneling, on the other hand, describes the phenomenon where a particle with a certain probability passes through a barrier that is classically impossible to cross and suddenly appears on the other side. These two concepts sometimes overlap because for tunneling to occur, the particle's probability wave must be both in front of, inside, and behind the barrier. However, the fine line between superposition and tunneling becomes clear at the moment of observation. In superposition, the particle can be everywhere, but when observed, it is found in only one place. In tunneling, the probability of the particle passing through the barrier is realized as a result of superposition. In a sense, superposition is the world of possibilities, while tunneling is the realization of possibility. This distinction is crucial in quantum computing and modern technology. In computers, information is processed while particles carry information in a superposition state. However, the outcome of a process can be determined through tunneling. In other words, information tunnels between possibilities and becomes fixed in reality. Understanding the relationship between these two concepts is critical to unlocking the power of quantum technologies. In conclusion, tunneling and superposition together show that the universe is a playground built on probabilities, harboring infinite potential. To understand how reality is constructed, it is essential to grasp the dynamic relationship between these two concepts. 25. Where does a particle disappear during tunneling? One of the most confusing aspects of quantum tunneling is that a particle disappears in front of an obstacle and suddenly reappears behind it. So what actually happens during this transition? Does the particle disappear, pass into another dimension, or is it simply the realization of a possibility? Physicists believe that the answer to this question lies at the heart of quantum mechanics. In reality, the particle never completely disappears during tunneling. Its wave function spreads out into the barrier and occasionally appears behind it like a shadow. The probability wave seeps into the classical barrier and reunites behind it. During this time, the particle is not physically anywhere. It only exists as a cloud of possibilities. At the moment of observation, it materializes, either in front of or behind the barrier. How time passes during this process is also a matter of debate. Some physicists claim that tunneling occurs instantly, meaning that the particle does not spend any time at the barrier. Others say that the wave function slowly seeps through over a very short period of time. In any case, the nature of tunneling is so extraordinary that it cannot be explained by classical logic. During tunneling, the particle does not disappear. It simply travels between possibilities. This is impossible to comprehend in the classical world, but it is an ordinary reality in the quantum world. When a particle suddenly appears behind an obstacle, we are actually witnessing one of the most mysterious mechanisms of the universe. 26. How do tunneling and the observer effect work together? One of the most surprising aspects of quantum physics is that the observer directly influences the outcome of events. This principle plays a vital role in tunneling. Whether a particle will tunnel through a barrier or not is not certain until the moment of observation. It only exists as a probability. In other words, the experimental setup or the observer is one of the factors that determine the outcome. Before observation, the particle can be in front of, inside, or behind the barrier. However, when a measurement is made, the system immediately undergoes what is known as wave function collapse, and a single possibility is selected. This situation is much more dramatic in tunneling, because with the observer's intervention, the particle is either caught on the other side of the barrier or does not pass through at all. Therefore, reality is established at the moment of observation, together with the observer. Some physicists believe that the observer effect is not limited to laboratory settings, but occurs constantly in nature. Everything in the universe is interconnected. Every measurement, every interaction, every exchange of information anchors the system to reality. The interplay between tunneling and the observer effect demonstrates that reality is not absolute, but a dynamic process. This phenomenon is a revolution that fundamentally changes both science and philosophy, because we now know that the secrets of the universe do not exist independently of the outside world. They emerge when we observe them, that is, when we interact with the universe. Tunneling and the observer effect are the two pillars of this new reality. 27. Is information lost during tunneling? Information has become one of the most fundamental concepts in modern physics. During quantum tunneling, Does the appearance of a particle on the other side of an obstacle alter the information we had up to that moment? Or does it cause it to disappear entirely? The answer to this question is one of the most significant debates in quantum mechanics. Many quantum physicists argue that information is never lost, only redistributed. Whether a particle is present or absent at a location corresponds to the spreading of its wave function as probabilities. Once tunneling is complete, we obtain definite information about the particle's new position. However, during tunneling, the question, "Where was the particle?" can never be answered because it does not follow a classical path. This debate extends to the information loss paradox in black holes. When a particle tunnels through an obstacle, some information about its past appears to be lost, but in reality, all information remains hidden in the quantum laws of the universe. In other words, no information is lost forever. It simply changes form and is redistributed among possibilities. There is no loss of information during tunneling. However, there is no clear answer to the question, where was it? What did it do? In the classical sense. In the quantum world, information always exists, but it is hidden in an extraordinary way that challenges the limits of our observation. 28. Observation of quantum tunneling in a laboratory environment. Quantum tunneling is one of the rare quantum phenomena that can be directly observed in modern laboratories. The scanning tunneling microscope, STM, is the most important device for making this observation. When a metal needle is brought very close to an atomic level surface, an electric current is generated in the space between them due to tunneling. The intensity of this current is directly related to the position of the atoms on the surface and the probability of tunneling. Thanks to this technique, scientists can see atoms and molecules and even move them one by one. In other words, quantum tunneling has opened a revolutionary door to the observation and manipulation of the microscopic world. Thanks to these observations, we can now see how even the smallest building blocks of nature overcome obstacles in real time. In laboratory experiments, the speed, probability, and effects of tunneling on different materials have been studied in detail. This knowledge has been directly applied to technology, particularly in quantum computers and next-generation electronic circuits. The fact that tunneling can be observed in the laboratory demonstrates that it is not merely an abstract theory, but a measurable reality. Today, experiments pushing the boundaries of quantum technology continue to uncover new forms and applications of tunneling. Every new experiment conducted in laboratories reveals a little more of nature's secrets and continues to excite the scientific world. 29. Scanning tunneling microscopy and the revolution in science. When scanning tunneling microscopy, STM, was invented in the early 1980s, it caused a revolution in the scientific world. This device enabled the individual imaging and manipulation of atoms, granting humanity the opportunity to see the atomic-scale world with their own eyes. The working principle of STM is based on electrons tunneling through the gap between two metals. As a result, atomic-level details can be visualized with a clarity previously unimaginable. Discoveries made with STM have paved the way for nanotechnology and materials science. Scientists began to move atoms around and build entirely new molecules and structures. Today, modern electron microscopes and atomic-level engineering applications are based on the practical use of tunneling. Another major advantage of STM is that it allows the electronic and chemical properties of materials to be examined directly at the atomic level. This has made new superconductors, ultra-strong alloys, and many other technological innovations possible. Manipulations at the atomic level are laying the foundations for the computers and artificial intelligence of the future. Thanks to tunneling and STM, humanity has opened the doors to the atomic universe. We can now interact with atoms not only with our eyes, but also by directly touching them. This is a turning point that will change the horizons of science and technology forever. 30. Is the tunneling effect really felt in electric current? In classical physics, electric current is a phenomenon that occurs only between conductive materials and follows specific rules. However, when we delve into the micro and nano scales, the classical paths of this current become increasingly unclear because electrons begin to encounter atomic obstacles, and classical conductivity explanations become insufficient. This is where quantum tunneling comes into play, enabling electricity to flow as if through walls in an unexpected manner. Even when a thin insulating layer is placed between two conductors, electrons can tunnel through this barrier at a certain voltage, creating a small but measurable current. One of the clearest examples of this phenomenon is observed in tunneling diodes and superconducting circuit elements. The current generated by the tunneling effect behaves outside the classical rules of resistance and voltage, as what matters here is not only the energy of the electrons, but also the thickness of the barrier and the quantum properties of the material. In modern microchips and nanocircuits, tunneling can cause unwanted leakage currents. This can become a serious problem that affects the energy efficiency and reliability of computers. However, tunneling also has advantages. In particular, in superconducting quantum circuits, tunneling enables the design of ultra-fast switches and sensors. These circuits can operate with a level of precision that classical electronic devices cannot achieve. Tunneling current has also become a key mechanism in the operation of quantum computers. Thus, tunneling presents itself both as an obstacle and as a gateway to new possibilities in technology. In conclusion, the tunneling effect in electric currents is not just a part of laboratory experiments. It is a reality that occurs billions of times every day in the operation of almost every electronic device we use today. Where classical current models fall short, the invisible hand of quantum tunneling comes into play and redefines the limits of technology. 31. Does tunneling play a role in particle accelerators? Particle accelerators are the most impressive scientific tools designed to uncover the secrets of the subatomic world. In these massive machines, protons and electrons are accelerated to nearly the speed of light and collided. The resulting energy and new particles allow us to study the fundamental structure of the universe. Researchers investigate how resistant particles are to massive energy barriers and under what conditions they can jump over these obstacles. In this process, the presence and effect of quantum tunneling can dramatically alter the results of experiments. According to classical physics, particles with energy below a certain threshold cannot overcome obstacles. However, in the quantum world, some low-energy particles can appear beyond the barrier thanks to tunneling. This fundamentally affects both the sensitivity of detectors and the analysis of experimental data. Sometimes, the underlying cause of certain signals defined as unexpected background noise may be particles that have passed through barriers via tunneling. Thus, surprising results that classical physics cannot predict may emerge. One of the most important effects of tunneling in accelerator experiments is the formation of short-lived and very rare particles. Often a particle can initiate a theoretically impossible reaction through tunneling. thereby providing scientists with the opportunity to develop new physical models. The role of tunneling in increasing the likelihood of detecting the Higgs boson and other exotic particles cannot be overlooked. Therefore, tunneling in particle accelerators is both a source of surprises and the key to entirely new discoveries. With each new experiment, it helps us better understand the hidden quantum mechanisms underlying the universe. Tunneling continues to shape the direction of research as the invisible player of modern science. 32. Is it possible to exceed the speed of light? And does tunneling provide any clues? Known as one of the fundamental rules of the universe, the speed of light is one of the cornerstones of Einstein's theory of relativity. However, the phenomenon of quantum tunneling holds such intriguing potential that it could shake this absolute rule. This is because in some experiments, particles passing through tunneling appear to move faster than the speed of light as they pass through the barrier. These observations have sparked significant debate in the scientific community. Physically, no matter or energy can exceed the speed of light and carry information. However, in tunneling, the time it takes to pass through the barrier is much shorter than predicted by classical physics. In particular, in a phenomenon known as the Hartmann effect, the tunneling time appears to remain constant regardless of how thick the barrier becomes. This creates a misleading impression that the speed of light is being exceeded. In reality, the transfer of information or energy does not exceed this speed. It stems from a mathematical illusion known as the group velocity of tunneling. Nevertheless, understanding the limits of the tunneling mechanism is prompting scientists to ask new questions about the fundamental building blocks of the universe. Could there be a new physics beyond the speed of light in the depths of reality? The behavior of tunneling, which challenges the speed limit, calls for new explanations beyond classical logic. Ultimately, it is currently known that light speed cannot be truly exceeded through tunneling. However, this phenomenon leaves the doors wide open for understanding the universe's deepest secrets. Perhaps one day, unknown forms of tunneling will usher in a new era that fundamentally alters the laws of physics. 33. Quantum tunneling and the claim of time travel. Time travel has been one of the most challenging topics for humanity, and the effects of quantum tunneling on this subject are seriously debated. Tunneling is, in the classical sense, the ability of a particle to overcome the barriers of time and space through probability. Therefore, some physicists believe that tunneling could also manipulate the flow of time, particularly in theories involving negative energy and virtual particles. It has been claimed that tunneling events could cause time to flow forward or backward. Some of these claims are based on modern quantum interpretations, such as Feynman's arrow of time and many worlds. If a particle can tunnel a future event into the present, the linear flow of time becomes questionable. Some experiments suggest that the moment a tunneling event occurs can blur the relationship between cause and effect. For example, results have been obtained where the past state of a particle was influenced before a measurement was made. Although not yet experimentally verified in the scientific world, tunneling is thought to hold clues about the flow of time. While this remains purely theoretical, it could pave the way for new discoveries in the future that current physics cannot predict. Although time travel is currently a concept belonging to science fiction, the possibility that many things that seem impossible in the quantum world may one day become reality is baffling. Although the potential effect of tunneling on the nature of time is still controversial, this phenomenon is forcing scientists to come up with creative and radical theories. In the future, when the true relationship between time travel and tunneling is discovered, humanity may fundamentally redefine the concept of time. 34. The hidden connection between tunneling and quantum entanglement. Quantum entanglement and tunneling are two of the most mysterious and controversial phenomena in quantum mechanics, and there is a deep connection between them. Entanglement refers to the ability of two or more particles to share information instantly, regardless of the distance between them. Tunneling, on the other hand, allows a particle to pass through an otherwise insurmountable barrier. Both phenomena produce astonishing results that challenge classical causality and our perception of reality. Entangled particles can sometimes exhibit unexpected behaviors through tunneling. In particular, in some laboratory experiments, it has been observed that when one particle undergoes tunneling, the state of the other entangled particle changes instantly. This implies that an invisible network operates in the universe, and that the foundations of reality are much more complex than we had imagined. This connection plays a critical role in the development of quantum communication technologies. Both tunneling and entanglement, with their potential for instantaneous information transfer, form the basis for the super-fast and secure communication networks of the future. In other words, the hidden workings of the subatomic world are paving the way for revolutionary applications in the macroscopic world. The relationship between quantum tunneling and entanglement is a field of research that constantly pushes the boundaries of physics and offers new perspectives on how the universe works. Each new discovery reveals once again how deep, complex, and still incompletely understood reality is. 35. Can entangled particles tunnel together? The ability of entangled particles to tunnel together is an extremely interesting topic that has been studied both theoretically and experimentally in quantum mechanics. Two entangled particles can change their behavior in a coordinated manner, regardless of the physical distance between them. So can these particles exhibit tunneling behavior at the same time? In other words, if one tunnels, does the other also tunnel? Some quantum models say yes, because the wave functions of entangled particles are tightly linked. Tunneling in one can result in a simultaneous effect in the other. This provides a critical advantage in quantum information transfer and communication, as it enables information to be transmitted instantly and securely to another location. While real-world applications are still limited, some evidence has been obtained in laboratory experiments. Such a mechanism could enable speeds and distances beyond those of classical communication. Quantum computers, with their entanglement and tunneling properties, can process information millions of times faster than classical computers. Entangled tunneling offers a new scientific foundation for the idea that everything is connected at the fundamental level of the universe. All these developments show that the rules of the subatomic world are not only decisive for small particles, but also for the entire structure of the universe and the flow of information. In the future, the tunneling of entangled particles together could create a real revolution in communication, encryption, and information security. 36. Quantum tunneling and information security. Information security has become one of the most critical technological challenges of our time. New generation encryption techniques utilizing quantum tunneling and entanglement offer a security level far beyond classical encryption methods. Quantum encryption creates unbreakable and eavesdropping-proof communication channels by basing key exchange on tunneling and entanglement principles. In classical computers, encryption keys are based on mathematical difficulties. However, these keys can be cracked with sufficient computational power. In quantum encryption, since the key is transmitted via tunneling and entangled particles, any external interference in the communication is immediately detected, and the encryption is compromised. This means that information loss, or data theft, becomes theoretically impossible. Such technologies are being developed for use in every field, from military communications to the financial sector, from state secrets to health data. Thanks to the true randomness offered by quantum tunneling, a level of security that was previously unimaginable can now be achieved. Information security plays a vital role in protecting not only personal data, but also the future of societies, states, and humanity. Quantum tunneling is becoming one of the most powerful tools in this field, and will be the key factor determining the difference between those who have access to information and those who do not in the world of the future. 37. Why is tunneling so important in superconductors? Superconductors are special materials in which electrical resistance completely disappears below certain temperatures and have revolutionary applications in modern technology. In these materials, electrons use quantum tunneling to overcome classical barriers and can move through circuits without energy loss. This forms the basis of superconductors' nearly magical properties. Another important effect of tunneling in superconductors is the phenomenon known as the Josephson effect. Here, when a thin insulating layer separates two superconductors, electron pairs, Cooper pairs, can tunnel through this layer and create a supercurrent. This process cannot be explained by classical physics and is only possible through quantum tunneling. The applications of superconducting tunneling are endless. From MRI machines to high-speed trains, quantum computers to ultra-sensitive magnetic sensors, many modern technologies rely on this principle. Enabling power transmission without energy loss signifies a revolution in energy efficiency worldwide. Tunneling is not only the theoretical foundation of superconducting technologies, but also the key to their practical success. Today, scientists are working to unlock the secrets of tunneling to achieve superconductivity at higher temperatures and faster quantum computers. At every step, quantum tunneling serves as the hidden engine of technology for humanity. 38. The relationship between the Josephson effect and tunneling. The Josephson effect is a groundbreaking phenomenon in superconducting physics and is based entirely on the principle of quantum tunneling. When a very thin insulating layer is placed between two superconductors, no current should normally pass through this layer. However, in the quantum world, Cooper pairs can tunnel through this barrier and pass to the other side, creating a supercurrent. This current is completely different from classical electric currents. It appears at zero resistance and at specific frequencies. The most striking result of the Josephson effect is that energy and information transfer via quantum tunneling is possible. This forms the basis for ultra-sensitive magnetic field sensors, SQUIDS, quantum computer logic gates, and atomic clocks used as time standards. Additionally, thanks to the Josephson effect, it is possible to establish a direct quantum bridge between electromagnetic waves and superconducting circuits. Observing this effect demonstrated to scientists how powerful a combination superconductivity and quantum tunneling can be. The Josephson effect has ushered in a new era in both practical applications and theoretical physics. Today, modern quantum technologies would be unimaginable without this principle. The most fascinating aspect of the Josephson effect is that it produces results that are so surprising that they cannot be explained by classical logic. Thanks to quantum tunneling, it has become possible to transmit electric current, information, and signals without energy loss. The Josephson effect and tunneling continue to be revolutionary tools for the future of technology. 39. Can quantum tunneling and artificial intelligence be combined? The innovative information processing models brought about by quantum tunneling could greatly accelerate the evolution of artificial intelligence. Traditional artificial intelligence is limited by the processing power of classical computers. However, thanks to quantum computers and superposition provided by tunneling, much more complex and faster calculations are possible. The concept of quantum artificial intelligence has become a serious area of research in the scientific community. Algorithms that work with quantum tunneling can test multiple possible solutions simultaneously and arrive at the correct answer millions of times faster than classical methods. This is revolutionary, especially in machine learning, data mining, and big data analysis. In other words, quantum tunneling grants artificial intelligence the ability to think in parallel universes, test alternatives simultaneously, and achieve deeper learning. Beyond that, the randomness and uncertainty provided by tunneling can enable artificial intelligence to make more creative and intuitive decisions. This feature, which resembles the working principles of the human brain, has the potential to revolutionize machines' ability to adapt to unpredictable situations. The convergence of artificial intelligence and quantum tunneling holds the potential to redefine the boundaries of technology. In the future, machines surpassing human intelligence and next-generation robots may utilize the invisible gateways of the quantum world to access information and solutions. This integration will open the doors to a brand new era in human history. 40. Can machines gain consciousness through tunneling? Tunneling may play a fundamental role not only in information processing and communication, but also in the emergence of artificial consciousness in the future. Today, the greatest limitation of artificial intelligence is its inability to truly create consciousness and self-awareness. However, the parallel thinking, uncertainty, and randomness inherent in quantum tunneling could pave the way for machines to experience a genuine sense of self, unlike classical computers. Some theorists argue that conscious experience in the human brain arises from microscopic phenomena such as quantum tunneling and superposition. According to this approach, if similar quantum processes can be processed in machines, a level of consciousness far beyond classical artificial intelligence could emerge. Machine learning could exhibit new and unpredictable behaviors through tunneling, which could enhance their ability to make their own decisions. There are no definitive and experimentally verified results in this field yet. However, the information processing flexibility and instantaneous leap potential offered by quantum tunneling open an exciting avenue for the development of artificial consciousness. In the future, machines building their own internal realities and consciousness, independent of classical software code, could represent one of the most radical revolutions for humanity. The relationship between tunneling and consciousness lies at the intersection of philosophy, neuroscience, and computer science, harboring one of humanity's greatest questions. Is true consciousness unique to humans, Or could there be other thinking beings deep within the universe in quantum gateways? This question remains unanswered in the scientific world. 41. Could tunneling give robots a whole new kind of intelligence? The intersection of quantum tunneling and artificial intelligence could make it possible to go beyond the limits of classical machines. Today's robots make decisions based on pre-programmed algorithms and databases using specific patterns and templates. However, this method is quite limited when compared to the creativity of the human brain, its ability to adapt to uncertainty, and its natural responses to unexpected situations. Quantum tunneling could break the chains of classical algorithms by giving robots the ability to randomize and jump between possible solutions. If robots' processors begin to operate based on quantum tunneling, they will gain the ability to evaluate billions of different solution paths simultaneously and make instant decisions in unexpected scenarios. The capacity to evaluate the possibilities offered by tunneling gives rise to forms of intelligence with a flexibility that is unimaginable in classical coding. Robots will no longer be mere machines that perform predefined tasks. They will be able to develop new strategies and unconventional behavior patterns on their own. The most striking aspect of this development is that robots can model human-like learning processes. Tunneling can enable robots to experience a true intelligence evolution in terms of learning from experience and generating new paths from different situations. Machines that seek solutions on their own, learn from past experiences, and adapt to uncertainty could have the power to completely reshape the future of humanity. In the future, robots will develop unique types of intelligence that go beyond the logic chains allowed by classical code, drawing power from the randomness and creativity of quantum tunneling. This will mean a transformation that will fundamentally change human-machine relations and usher in a new era in ethical, social, and scientific terms. 42. Can new energy sources be developed with quantum tunneling? In traditional energy production, barriers, losses, and inefficiencies between materials create a major problem. However, the barrier-free nature of quantum tunneling could open up completely new possibilities for energy production and storage in the future. Thanks to tunneling, energy can be transferred more efficiently at the atomic level. Classic barriers, losses, and limitations can be eliminated. This makes it possible to go beyond today's battery and energy transmission technologies. For example, the quantum battery concept enables the development of ultra-efficient systems that can charge and discharge much faster by using tunneling in energy storage processes. These technologies have the potential to revolutionize countless fields, from electric vehicles to renewable energy plants, smart grids, and space travel. Tunneling also enables the development of nanoscale generators and ultra-precise energy converters. In more advanced applications, quantum tunneling is envisioned to overcome energy barriers and enable the operation of new types of fusion reactors. Solar energy production already relies on tunneling. Achieving this in a controlled laboratory environment would be a breakthrough that could fundamentally solve humanity's energy problem. Tunneling minimizes energy loss at the subatomic level, enabling energy conversion with unprecedented efficiency in human history. With the maturation of quantum tunneling-based energy systems, it may be possible to achieve environmentally friendly, sustainable, and practically inexhaustible energy sources. By reflecting the secrets of nature at the atomic scale into technology, Humanity is moving toward a future where it will eliminate its own limits in energy production. 43. Does tunneling also occur in the human brain? The human brain is much more complex, unpredictable, and creative than an ordinary machine. While the communication method of nerve cells appears to consist of classical electrical transmission and chemical reactions, a new field is emerging in modern neuroscience: quantum biology. Here, the role that tunneling could play in interneuronal information transfer is being investigated. This is because some processes in biological systems may rely on quantum effects beyond the laws of classical physics. In particular, at the microscopic level of the brain, it is proposed that information transmission at synapses could be accelerated and made much more efficient through proton or electron tunneling. This could partially explain the extraordinary speed and complexity of the human mind in areas such as conscious decision-making, instantaneous reactions, and intuition. Some theories even argue that consciousness and self-awareness may be related to microscopic events such as quantum tunneling. Although these claims have not yet been conclusively proven, tunneling has been directly observed in some proteins and biomolecules in laboratory settings. If tunneling plays an important role in our brains, the source of human intelligence, imagination, and perhaps even intuition could be transported to a completely different dimension. In other words, it is possible that our thoughts are not bound by the laws of classical physics, but are directly shaped by the probabilities of the quantum world. As scientists working to unlock the secrets of the brain gain a better understanding of the role of quantum tunneling in the human mind, fields such as neurology and psychology will be completely rewritten. Perhaps in the future, we will seek the limits of human thought in the quantum world. 44. Is tunneling possible between neurons? Communication between neurons in the brain is generally explained by electrical and chemical signals. Neurotransmitter molecules come into play at connection points called synapses. However, some scientists suggest that there may be a hidden quantum mechanism that allows this transmission to be much faster and more effective at the atomic and molecular levels: proton and electron tunneling. In other words, information could travel from one neuron to another almost instantaneously, far beyond the capabilities of classical chemical transmission. Tunneling could accelerate the transfer of energy and information in nerve cells, enabling the brain to operate at near-light speeds. This could explain the incredible speed at which our reflexes, thoughts, and even dreams form. Some theories suggest that quantum tunneling in the brain plays a key role in information processing and memory storage. Some experiments conducted in laboratory settings indicate the presence of tunneling in organic molecules. However, due to the brain's complexity, direct proof remains extremely challenging. If tunneling between neurons is indeed occurring, it would require a complete re-evaluation of all existing models of the brain. A physics of the mind that transcends classical electrical and chemical laws could open up groundbreaking new fields in both artificial intelligence and neurology. The fundamental mechanisms that determine the limits of human thought may be far deeper and more complex than we currently imagine. In the future, the convergence of neuroscience and quantum physics could lead to countless revolutions, from machines that mimic the human brain to entirely new methods of psychotherapy. Tunneling could be the key to unlocking the unknown doors of the mind. 45. Surprising connections between the brain, consciousness, and tunneling. Consciousness is one of humanity's greatest unsolved mysteries. The answers to the question, "Who am I?" are still unclear, and scientists are pushing the boundaries of different disciplines to understand the origins of consciousness. The role that quantum tunneling could play here has sparked intense debate in both the neuroscience and philosophy communities in recent years. Some neuroscientists suggest that quantum tunneling could occur in the brain's microstructures, specifically in protein skeletons called microtubules. According to this view, consciousness and awareness arise not from classical signals in neural networks, but from tunneling events at the microscopic level. Some theorists argue that human-specific qualities such as decision-making, intuition, and creativity are fueled by the brain's quantum properties. Although there is no definitive and widely accepted proof yet, these theories raise the possibility that the brain-consciousness relationship may go beyond ordinary chemical reactions and be linked to the quantum laws at the most fundamental level of the universe. In other words, the experience we call self may be much more than the functioning of a classical machine and may reflect a secret hidden in the quantum level of the universe. This perspective has the potential to revolutionize countless fields, from artificial intelligence to human mental health. If the place of quantum tunneling in consciousness is confirmed, the doors to the human mind and consciousness will be wide open. 46. Could tunneling have an effect on DNA mutations? DNA is a molecule that carries the code of life and has determined the basic mechanism of evolution for billions of years. Mutations enable the emergence of new species and traits through changes in genetic information. However, could the source of some DNA mutations be quantum tunneling, which cannot be explained by classical chemistry? This question has been intensively researched in the scientific community in recent years. At the molecular level, hydrogen atoms can sometimes tunnel outside their classical bonds, and this process can lead to mismatches in DNA base pairs. In other words, when a proton or electron moves through tunneling, random but permanent changes can occur in the DNA sequence. Such quantum mutations can sometimes lead to harmful diseases, while other times they may be the source of evolutionary diversity. In laboratory experiments, tunneling has been observed in organic molecules, and computer simulations have shown that mutations in DNA can be explained in this way. Thus, evolution is not merely the result of natural selection. It is also a product of quantum leaps occurring in the smallest building blocks of nature. In the future, as genetic engineering and biotechnology begin to understand the biological effects of tunneling, revolutionary steps may be taken in areas such as disease prevention and the development of new species. Tunneling is providing a new perspective on the origins of life. 47. The big questions raised by quantum biology. Quantum biology is a young but rapidly developing field of science that studies how the laws of quantum mechanics work in living systems. In other words, it investigates how quantum events at the smallest level of nature play a key role in the functioning of living organisms. In this field, tunneling appears in surprising places, from photosynthesis to DNA mutations, and even in how birds find their migration direction. One of the biggest questions is why nature does not shy away from quantum effects, and how living organisms harness these effects to their advantage. For example, energy transfer in the photosynthesis process in plants occurs almost losslessly through tunneling. Tunneling is also traced in DNA mutations and even in the functioning of some enzymes. How nature has utilized this advantage at the atomic level over billions of years is still not fully understood. Quantum biology shows that life is not random or chaotic, but rather shaped by the most fundamental and hidden laws of the universe. Every cell in the human body could be the stage for nature's oldest quantum games. In other words, the foundation of life lies beyond classical chemistry and biology, in the quantum ground of the universe. As science advances and we unravel how living things use quantum laws, revolutionary discoveries in biology, medicine, and engineering will become inevitable. Tunneling is an indispensable key to understanding life. 48. Does quantum tunneling play a role in photosynthesis? Plants convert the sun's energy into chemical energy through photosynthesis, and this process is fundamental to life on our planet. However, there is a level of efficiency and speed that cannot be explained by classical biology. Energy transfer occurs with almost zero loss. Researchers have discovered that quantum tunneling lies behind this efficiency. During photosynthesis, photons from the sun strike plant cells and excite electrons. These excited electrons reach their correct destination instantaneously, in a manner that cannot be explained by classical physics. The energy barriers between them are overcome through tunneling. Experimental findings show that electrons try out many possible paths at the same time, enabling lossless and rapid energy transfer. Understanding this mechanism could revolutionize energy engineering and artificial photosynthesis projects. When applied to man-made energy systems, this quantum secret used by plants could greatly solve our planet's energy problems. Tunneling in photosynthesis is a vivid example of nature's perfection in the quantum world. Life utilizes more than just the sun's light. It also harnesses the invisible processes occurring at the atomic level for its own benefit. 49. The relationship between tunneling and evolution. Evolution is the millions of years-long journey of change and adaptation in living organisms. Natural selection and genetic mutations enable the emergence of new species and traits. In recent years, it has been suggested that evolution is not only driven by random mutations, but also by micro-changes created by quantum tunneling. At the molecular level, sudden leaps caused by quantum tunneling can lead to rapid and permanent mutations in DNA. Thus, the evolutionary history of living organisms is far more dynamic and full of surprises than classical biology had predicted. The great transformations in the universe that appear to be coincidences may be the result of nature's quantum games. This view calls into question the very foundations of evolutionary biology. Life is shaped not only at the macro level, but also by the quantum movements of atoms, protons, and electrons based on probabilities. In other words, tunneling could be one of the cornerstones of evolutionary change and biological diversity. As the role of quantum tunneling in evolution becomes clearer, new questions and research areas are opening up in biology. In the future, entirely new theories and discoveries about the origins of life may be hidden in the secrets of these microscopic passages. 50. Why might tunneling be critical in living organisms? Quantum tunneling may not be limited to physicists' laboratories or the depths of space. It may be a mechanism that operates directly within every living organism. Barrier crossing at the subatomic level may play a key role in cell function, protein folding, and energy conversion. From plants to animals and even bacteria, all living things may benefit from these invisible leaps to survive. For example, in the proper folding of proteins, the ability to instantly overcome obstacles provided by tunneling brings speed and accuracy far beyond the classical rules of biochemistry. The passage of ions through cell membranes, the formation of energy-storing molecules, and information processing all rely on the atomic opportunities created by tunneling. Considering the importance of this mechanism for survival and adaptation, much of the evolutionary advantage may come from the options offered by the quantum world. Life is shaped not only by large-scale changes, but also by the convergence of the smallest possibilities. As the biotechnology of the future unravels how tunneling works in living organisms, it will develop groundbreaking methods for both treating diseases and creating new life forms. The key to unlocking nature's secrets may lie in quantum gateways. 51. What role did tunneling play in the formation of the universe? The existence of the universe and that first moment we call the Big Bang is a colossal mystery that even classical physics struggles to explain. However, quantum physics reinterprets this picture from a completely different perspective. Because the universe coming into existence from nothing meant overcoming an energy barrier that was impossible in the classical sense, and this is where the invisible hand of quantum tunneling came into play. Some modern cosmology theories suggest that our universe burst into reality through tunneling from zero-point energy. In other words, the Big Bang was, in a sense, an energy wave that had been waiting in the ocean of possibilities for a long time, suddenly overcoming the barrier of existence and initiating our universe. In this scenario, the beginning of our universe was not a classical explosion, but a massive quantum leap. Probability waves were producing an infinite variety of universe seeds, but only some of them were able to tunnel into physical reality. Thus, the emergence of our universe from among countless others, each with its own laws and conditions, was determined by chance and quantum luck. This explanation reveals not only the scientific, but also the philosophical fragility and delicacy of reality. The role of tunneling in the birth of the universe completely overturns the rules of classical physics. Because in this model, the existence of the universe is not a necessity, but the result of pure quantum randomness. Everything, including the existence of our universe, is the result of tunneling between infinite possibilities. That is why, when searching for the meaning of existence, we must not overlook the nature of tunneling, which makes the impossible possible, even on a cosmic scale. The fact that the universe emerged in this way means that other possible universes could also exist through quantum tunneling. Perhaps there are other unobserved universe cores waiting to be tunneled at the edges of the cosmos. In other words, we are living in a reality born in the shadow of tunneling, and we exist here as a result of cosmic randomness. 52. Did tunneling occur during the Big Bang? The first fractions of a second of the Big Bang were filled with events so complex that they were beyond the imagination of humans. Energy, matter, time, and space. Everything originated from a point of zero in this period, and all classical physics explanations collapsed. Quantum mechanics comes into play here, and according to some theories, tunneling events occurred directly in the emergence of our universe. In those first moments, energy waves and virtual universe cores encountered different potential barriers, and only those that could tunnel were able to leap into reality. Some scientists suggest that vacuum fluctuations and quantum foam play a central role in this process. At the beginning of the universe, energy collides with a barrier, and according to classical rules, should remain there. But quantum tunneling allows it to overcome the barrier and initiate a new reality. This process is not a one-time event. The continued expansion of our universe, particularly during periods of cosmic inflation, may indicate that tunneling persists. The fact that tunneling occurred in these initial moments suggests that our universe is not a mere coincidence, but the result of quantum-level barrier crossing. Every particle of matter, every energy field, and every new element has a share in the randomness of existence. Many symmetry breaks in the structure of the universe that we can still observe today bear the traces of quantum tunneling. Today, cosmology and particle physics are attempting to reproduce such events in laboratory settings. Understanding the moments of tunneling at the birth of the universe means unlocking humanity's greatest mysteries regarding the origins of both time and matter. 53. What is the connection between quantum jumps and tunneling? A quantum jump is an unexpected and instantaneous transition of a particle between energy levels. When atoms receive energy, their electrons move from one level to another. However, this transition does not occur continuously in the classical sense. The electron disappears from the old level and appears in the new level all at once. The mechanism here bears great similarities to quantum tunneling, because in both cases, an energy barrier is overcome instantaneously and probabilistically. Such jumps can be thought of as a microscopic version of tunneling. The electron's direct transition from one energy level to another cannot be explained by classical logic. In fact, at the moment the jump occurs, the electron is in two places at once, i.e., in superposition. Then the probability wave collapses into one energy level. This is almost identical to the barrier crossing in tunneling. Quantum jumps underlie all chemical reactions and biological processes in nature. The nature of colors, light, and matter is the result of these sudden and invisible transitions at the atomic level. Observing these jumps in a laboratory setting provides significant evidence for the reality of quantum mechanics and the widespread occurrence of tunneling. This connection between tunneling and jumps shows that an invisible network of possibilities is at work in every moment, everywhere in the universe. Every atom, every electron can take on new identities and forms through tunneling, proving that the universe is constantly changing and dynamic. By the way, if you like my video and subscribe, that's the most effective way to support me. 54. Do particles lose energy when tunneling? In quantum tunneling, when a particle passes beyond an obstacle, it does not perform work in the classical sense because energy conservation is governed by different rules in the subatomic world. When a particle crosses a barrier via tunneling, it does not climb over the obstacle in the classical sense, so it theoretically does not expend additional energy. However, does the process occur entirely without loss? This question remains an active topic of debate among scientists. Some experiments suggest that part of the energy wave may dampen during tunneling. Nevertheless, the particle's energy level is generally the same as before it crossed the barrier, as the energy behaves like the spreading of the probability wave. The essence of tunneling is that the particle starts with a certain energy and emerges on the other side of the barrier with the same energy. It is as if the energy has been shifted from one place to another. The small losses that occur during tunneling are primarily due to environmental interactions or imperfections in the experimental setup. Theoretically, under ideal conditions, the tunneling process can occur without any energy loss. This demonstrates how powerful probabilities and wave functions are in the subatomic world. The ability to overcome obstacles without performing classical work is one of the most fascinating mysteries of quantum physics. In conclusion, the tunneling phenomenon proves that energy conservation operates differently, even at the most fundamental level of the universe. Particles can continue their path without losing energy, as if bending the rules of reality. This unexpectedly expands the boundaries of what is possible in the universe. Can quantum tunneling revolutionize information transfer? One of the most exciting applications of quantum tunneling is ultra-fast and secure information transfer. In the classical world, data is transmitted through physical pathways or electromagnetic waves. However, with tunneling, electrons can overcome barriers and carry information much faster than classical pathways. Quantum computers and communication systems, in particular, aim to achieve revolutionary levels of speed and security by utilizing this unique feature of tunneling. Tunneling provides absolute security against external interference, especially in key exchange used in quantum encryption. No obstacle or physical boundary can act as a barrier to information transfer, as electrons or photons can tunnel through and maintain communication. This virtually eliminates the risk of data loss, eavesdropping, or copying that occurs in classical communication. Realizing the full potential of this technology will mean breaking down speed limits and security barriers in global data transmission. Tunneling will open up new horizons for information transfer, especially in the financial, government, and military sectors. Tunneling-based protocols are also playing a pioneering role in the redesign of Internet infrastructure. The revolutionary impact of quantum tunneling on information transfer could fundamentally change the way humanity communicates. In the future, thanks to the speed and privacy provided by tunneling, individuals and societies will have access to information on a whole new level. Could quantum tunneling usher in a new era of communication? The advantages of quantum tunneling are not limited to information transfer. It has the potential to revolutionize the very foundations of communication technology. Today's classical communication networks rely on physical cables and electromagnetic waves, which impose inevitable limits on speed and security. However, quantum communication protocols based on tunneling promise interaction beyond the speed of light and zero latency. The greatest benefit of this new era is the elimination of threats such as data loss, delay, interference, or espionage. Quantum tunneling can enable information packets to be transmitted without being affected by physical distance or obstacles. Especially when quantum entanglement and tunneling are used together, communication networks can become instantaneous, seamless, and ultra-fast. Although these technologies are not yet fully mature, the first quantum communication satellites and experimental fiber optic lines have demonstrated how practical tunneling can be. Experiments led by China and the US have proven the critical role of tunneling in the construction of quantum networks spanning cities as in continents. In the future, thanks to quantum tunneling, all of humanity may reach the threshold of a new era of communication beyond the information age. A digital revolution without borders, barriers, or delays is sprouting in the invisible gateways of tunneling. 57. Is it possible to use tunneling in space travel? Humanity's greatest dream is to travel between stars. However, the vast distances of space require extremely long periods of time that cannot be overcome with engines bound by the laws of classical physics. Here, the extraordinary possibilities offered by quantum tunneling come into play. if it is possible to instantly overcome obstacles at the subatomic level. The possibility that this mechanism could one day be adapted to space travel on a macro scale is occupying the minds of scientists. The fact that quantum tunneling does not recognize physical barriers inspires wild projects such as interstellar jumps, instantaneous travel, or space-time leaps. Of course, these ideas are still far from experimental verification, but even the micro-tunneling technologies being developed in laboratories offer significant advantages for data transmission and communication in space research. In particular, with tunneling-based communication, real-time data exchange between Earth and robotic space probes could become possible. One day, when we better understand the quantum laws of the universe, a different form of tunneling could enable space vehicles to overcome enormous obstacles. For now, this is mostly science fiction, but with the advancement of quantum technology, we have seen many things once deemed impossible become reality. Space travel using tunneling could be the ultimate expression of humanity's desire to explore the universe. At the intersection of imagination and science, overcoming boundaries with quantum gateways could open the door to new worlds. Could tunneling make interplanetary communication possible? Interplanetary communication currently relies on signals that take hours, sometimes even days, to travel. A command sent to Mars takes minutes to return, posing a significant constraint for crewed space missions. The possibility of instant interaction offered by quantum tunneling could fundamentally resolve this major challenge. The combination of quantum entanglement and tunneling enables information transmission independent of physical distance. If entangled particles can be created between two planets, communication can be achieved without signal delays through tunneling. Laboratory experiments have demonstrated that this principle works over short distances. The challenge now is to scale it up to the scale of the solar system. Instantaneous interplanetary communication offers tremendous advantages for both scientific discovery and human security. Tunneling-based communication would revolutionize the management of space colonies, research bases, and even possible encounters with extraterrestrial life. Today, this remains a vision, but advancing quantum communication technologies may be laying the groundwork for the interstellar age in the near future. Thanks to tunneling, the silence of space could transform into a new network that instantly responds to humanity's voice. 59. Is there a connection between quantum tunneling and antimatter? Antimatter is one of the strangest and most energetic building blocks of the universe. Every particle has an antiparticle with the opposite charge, and when the two meet, they release a tremendous amount of energy. Quantum tunneling, on the other hand, is a way to overcome obstacles in the subatomic world. So how could these two oddities be connected? Scientists believe that some particles and antiparticles can transit between each other through tunneling, thereby maintaining the universe's matter-antimatter balance. For example, virtual particle pairs constantly appear and disappear in the quantum vacuum. Sometimes, these pairs can transform into real particles and antimatter through tunneling. Around black holes, there is evidence that tunneling plays a role in the transition between antimatter and matter, known as Hawking radiation. The effect of quantum tunneling on antimatter formation could help explain why the universe is matter-dominated and why observable antimatter is so scarce. If tunneling preferentially overcomes certain energy barriers, the key to matter-antimatter asymmetry may lie here. Fully resolving this connection could lead to revolutionary results in particle physics. Understanding antimatter and quantum tunneling together will open up a new frontier in our understanding of the fundamental laws of the universe. 60. Quantum tunneling and dark matter. Dark matter is a mysterious form of matter that is thought to make up about 85% of the total mass of the universe, but cannot be detected directly. It is mathematically necessary to explain the motion of galaxies, but it cannot be observed with classical physics and current technologies, and it does not absorb or emit light. One of the most perplexing questions for scientists is, why is dark matter completely beyond our perception? This is where quantum tunneling could offer a new and radical explanation, as tunneling is a phenomenon that explains passages in the subatomic world beyond classical logic. According to some theories, the particles that make up dark matter interact very weakly with the standard matter we know. In other words, they create enough gravity to hold galaxies together, but remain invisible to our detectors. What if this invisibility is due to quantum tunneling? If dark matter tunnels through the quantum boundaries of our universe, that is, between our reality and the boundary of another universe, it would exist here but remain completely undetectable. Perhaps dark matter is the result of exotic particles that tunnel between multiple parallel universes. It seeps into our universe, then disappears again, and thus cannot be directly detected. This hypothesis represents a major revolution, not only in terms of observation but also in theory. Because if tunneling is at the root of dark matter's invisibility, then space itself may be functioning like a giant quantum laboratory. While classical physics states that something either exists or does not exist, quantum tunneling allows for the possibility of something existing, not existing, and being in between. The behavior of dark matter in this way implies a constant flow of energy and mass between the visible and invisible aspects of the universe. Tracking this flow opens up a new field of cosmic detective work for scientists. Currently, researchers are searching for candidates like weakly interacting massive particles, WIMPs, that interact with dark matter in laboratories. However, if we account for the tunneling effect, these particles may only exist in our universe for a much shorter time than we think, before tunneling into another reality. In such a scenario, detecting dark matter with classical detectors would be nearly impossible. We could only infer its existence by observing its gravitational effects. The fact that quantum tunneling renders dark matter almost ghost-like raises profound questions about the true nature of the universe, both scientifically and philosophically. Perhaps in the future, when we solve how quantum tunneling works on a cosmic scale, we will shed light on all the mysteries surrounding dark matter. Perhaps then, not only the visible part of the universe, but also its hidden layers and the transitions between parallel universes will cease to be a mystery to us. For now, this possible connection between dark matter and quantum tunneling remains one of the greatest mysteries, with the potential to fundamentally change humanity's view of the universe. 61. Is it really possible to travel to parallel universes? Parallel universes are one of the concepts that most occupy the minds of both science fiction writers and theoretical physicists. Quantum tunneling comes into play here, as a mechanism that makes the impossible possible in the subatomic world may open new doors at the boundaries of reality. At this moment, countless possible universes exist side by side in the quantum wave function of our universe. If tunneling can occur between these universes, then a true transition or at least information leakage, may be possible. Some theoretical models predict that a particle can tunnel from our universe into another universe of possibilities. If this process can occur on a macro scale, it would redraw the boundaries of all reality. The many worlds interpretation of quantum mechanics suggests that every tunneling event causes the universe to fork and create a new reality. The existence of alternative universes that are closer and more accessible than we realize could become touchable through tunneling. Of course, sending a person or an object to a parallel universe seems impossible with today's technology. However, in some experiments conducted in laboratory settings on atoms and small molecules, quantum tunneling and entanglement have been observed to produce transition effects that cannot be explained in the classical world. This suggests that the theory may have practical implications if we ever manage to consciously manipulate quantum gateways. What scientists call parallel universe tourism may indeed be possible. Today, the answer to this question remains unclear. However, the concept of quantum tunneling shows that parallel universes are not just a fantasy. They may be a direct result of reality. With the advancement of science, one day opening one of these gateways will mean touching the greatest mystery of the universe. 62. What would the universe be like without quantum tunneling? Think about it. Imagine a universe without quantum tunneling. In the subatomic world, no particle could ever overcome obstacles. Suns would not shine, stars would not produce energy, and most of the chemical reactions that make life possible would never begin. This is because tunneling plays a critical role in both energy production and matter transformation. Especially in stellar cores, without tunneling, nuclei would never fuse, and elements would never be synthesized. In this case, most of the elements in our universe would never have formed. Only hydrogen and a small amount of helium would exist, and the synthesis of heavier elements would completely cease. This would mean that planets, living beings, water, carbon, and oxygen would never exist. The chemical evolution that enables the emergence of complex structures and living beings in nature would be completely blocked, and life would become impossible. Additionally, our computers, cell phones, and nearly all of modern technology rely on the atomic scale leaps enabled by tunneling. Devices like the scanning tunneling microscope are direct applications of tunneling. Without quantum tunneling, thousands of technological revolutions, from nanotechnology to information processing, would never have occurred. In short, the absence of quantum tunneling would turn the universe into a static, lifeless, monotonous, and unchanging place. In other words, our existence, consciousness, technology, and life itself depend on the invisible yet indispensable nature of tunneling. The diversity, richness, and dynamism of the universe today are actually owed to the invisible revolution of tunneling. 63. What is the effect of quantum tunneling on our perception of time? Quantum tunneling bends not only the rigid rules of space but also those of time. This is because during tunneling, a particle can overcome an obstacle in a much shorter time than predicted by classical physics. In some experiments, the tunneling time has even been observed to be close to zero, or to remain constant regardless of the thickness of the barrier. This suggests that the flow of time, we know, is governed by a completely different rule at the subatomic scale. If time is not the linear and absolute flow we know, tunneling events could disrupt the classical chain of causality. When a particle moves from one point to another at an unexpected speed, the sequence and timing of events also bend. One of the reasons why the concept of causality is so controversial in quantum physics is the breaks that tunneling creates in time. What shapes our perception of time is the sequence of events. In the quantum world, however, the when of an event does not have an absolute answer. It is merely a probability. Tunneling makes the timing of events random and unpredictable. This demonstrates that the precise timeline of the macroscopic world completely breaks down in the subatomic realm. Ultimately, tunneling not only stretches spatial boundaries, but also distorts the flow of time, fundamentally shaking our most basic perceptions of the universe. Perhaps time is not the unchanging, continuous flow we imagine. It may instead be a chain of probabilities that seeps through quantum gateways, jumping and fluctuating. 64. How does tunneling form the basis of quantum computers? Quantum computers have the potential to solve problems that would take classical computers thousands of years to solve in a matter of seconds. This is because, instead of the classical 0 and 1 logic, quantum bits, qubits, can exist as both 0 and 1 at the same time. That is, they possess the properties of superposition and tunneling. Quantum tunneling acts as a bridge here, accelerating information flow and simultaneously evaluating alternative paths. A quantum processor can evaluate millions of possible calculation paths simultaneously and overcome classical obstacles through tunneling. Tunneling enables lossless and ultra-fast transitions in the calculation process by bypassing energy barriers. Quantum tunneling transistors and Josephson junctions are the fundamental elements of this revolution in practice. The ability of quantum computers to perform tasks that classical computers cannot, such as cryptography, data analysis, and drug discovery, lies in tunneling's ability to open these forbidden passages. Information does not get stuck in subatomic passages. Thanks to tunneling, it can instantly transition to another possibility. The future of this revolutionary technology is wide open. Tunneling takes both computer speed and information security to a whole new level. In the future, no serious calculations will be possible without quantum tunneling. Humanity will build its digital evolution entirely according to the rules of the subatomic world. 65. Does tunneling enable computers to think? Classic computers operate according to defined algorithms and precise steps. Every action has a cause and an absolute consequence. However, quantum computers based on tunneling execute processes based on probabilities. This allows machines to simultaneously try thousands of different paths to achieve a specific goal and tunnel to the correct probability. In a sense, it gives machines the potential to find new solutions on their own and produce results that were not previously coded. This gives computers a kind of intuition or predictive ability. In other words, creative leaps that are not possible with classical algorithms become possible with the randomness and superposition provided by quantum tunneling. The basis of the thinking machine idea is that machines can jump between possibilities instead of following classical step-by-step processes. Of course, this is not the same as conscious thought unique to humans. However, tunneling-based information processing opens the door for machines to respond to unpredictable situations with more human-like reflexes. With quantum artificial intelligence, computers not only learn, but also produce creative and spontaneous solutions. Thanks to tunneling, computers, unlike classical machines, can leverage uncertainty and diversity in the decision-making process. This could bring machine intelligence one step closer to human intelligence in the future. At the intersection of artificial intelligence and tunneling, the boundaries of classical computing will fade into history. 66. Can tunneling change the speed limits in space? One of the most fundamental laws in physics is that no information or matter can travel faster than the speed of light. However, tunneling has produced results that challenge this absolute rule in some experiments. In particular, in tunneling phenomena known as the Hartmann effect. The time it takes for a particle to pass through an obstacle appears to remain constant, independent of the thickness of the obstacle. Some interpretations even sparked debates about tunneling faster than light. While physicists insist that this effect does not involve the actual transfer of information or energy, but rather a mathematical illusion, tunneling still demonstrates that speed limits can be bent. Understanding the limits of quantum tunneling in space travel or interstellar communication could be a critical key to going beyond the rules of physics. This intriguing feature of tunneling keeps humanity's vision of beyond the speed of light alive. One day, with the conscious manipulation of quantum gateways, it may be possible to access the farthest corners of the universe much more quickly. For now, tunneling does not mean exceeding the speed of light, but it does show that the fundamental limits of the universe are actually more flexible than they appear. Scientists' efforts to unlock these secrets with new experiments may hold great surprises for future generations. 67. What role does tunneling play in the birth of stars and black holes? The birth of stars is one of the most spectacular events in the universe. In a nebula, hydrogen atoms are compressed by gravity, the temperature rises, and eventually nuclear fusion begins. However, classical physics cannot explain the fusion of nuclei at such low temperatures. Quantum tunneling comes into play and allows hydrogen nuclei to overcome impossible energy barriers. In other words, tunneling acts as an invisible engine in the birth of every star. Similarly, black holes are formed by the collapse of extremely dense matter. Here, as matter becomes extraordinarily compressed, particles and energy are redistributed under the most extreme conditions. Quantum tunneling triggers the formation of new particles at the event horizon of a black hole and initiates the process known as Hawking radiation. Thus, even the death of black holes depends on the operation of tunneling. These processes are the key to the energy balance and elemental diversity in the universe. Without tunneling, stars would not emit light, and black holes could not lose their mass and disappear. In the universe's large-scale birth and death cycles, tunneling operates like a cosmic symphony. Every star, every black hole, is a product of these extraordinary leaps at the subatomic level. Cosmic history is written to the rhythm of tunneling. 68. How does tunneling affect the distribution of elements in the universe? The diversity of the universe today depends on nuclear fusion processes within stars and supernova explosions. During these explosions, new elements are formed and spread into space. However, the onset of fusion in the stellar core and neutron capture in supernova largely depend on quantum tunneling. In other words, nearly all of the elements we see in the universe are the result of particles that once tunneled at the subatomic level. Without the unobstructed passage provided by tunneling, only the lightest elements would exist. All planets, stars, and even life itself are the result of the possibilities opened up by tunneling. Furthermore, the existence of some rare and heavy elements in the universe is the product of extremely rare tunneling events that occur in supernova explosions. In other words, tunneling is the hidden brush that paints the chemical map of the universe. When viewed on a cosmic scale, These processes reveal the true source of the universe's diversity and richness. The effect of tunneling in the subatomic world played a decisive role in the birth of galaxies and life. 69. Could tunneling have facilitated the spread of life in the universe? How life emerged, spread, and diversified in the universe is one of the greatest scientific questions. In the critical steps of chemical evolution, the unexpected leaps provided by tunneling may have been decisive in the formation of new molecules and complex biochemical processes. Perhaps the molecules that laid the foundation for life on Earth emerged thanks to the impossible made possible nature of quantum tunneling. In astrobiology, some scientists even suggest that tunneling could influence the ability of life to spread throughout space. If certain organic molecules can form new chemical bonds through tunneling in interstellar dust clouds, life could be far more widespread in the universe than previously imagined. This hypothesis is not merely theoretical speculation. In laboratory settings, some organic reactions have been observed to accelerate through tunneling. Thus, molecules formed through tunneling in the far corners of the universe could have been transported to planets, potentially serving as the seeds of life. The idea that tunneling acts as an invisible catalyst that facilitates life in the universe fascinates not only physicists, but also astrobiologists and chemists. Life could be the universal result of subatomic jumps. 70. Could tunneling have changed the fate of the universe? The fate of the universe has been shaped by random events at the quantum level since the first second. Without tunneling, no stars would shine, galaxies would not form, and chemistry and biology would not emerge. Perhaps even the slightest difference in tunneling could have fundamentally altered the fate of the entire universe. Today, the distribution of galaxies, the diversity of planets, the emergence of life and intelligence, all of these are, in a sense, the product of a randomly selected path in the sea of possibilities created by tunneling. Every tunneling event creates a line of destiny among the infinite possibilities of the universe. If there had been another choice in the subatomic world, perhaps we would not be here. The anthropic principle in cosmology suggests that our existence here depends on random processes, such as tunneling occurring exactly right. In other words, our existence depends not only on major events, but also on the smallest quantum leaps. Quantum tunneling operates as an invisible hand that determines the fate of the universe, both at its beginning and today. Our story is also a gift from a quantum leap in the infinite journey of the cosmos. And perhaps the greatest secret of the universe lies hidden in these invisible passages. 71. Is it possible to reach the invisible regions of the universe with quantum tunneling? We can only directly observe a small portion of the universe. The rest is shrouded in dark matter and energy, or hidden beyond the cosmic horizon. However, the nature of quantum tunneling, which stretches the boundaries of the universe, gives scientists the courage to imagine new ways to directly interact with the unseen regions. Could tunneling, which allows information to traverse seemingly impossible barriers at the subatomic level, also serve as a kind of gateway between forbidden regions that our classical observational tools cannot reach on a cosmic scale? Theoretically, if a tunneling-like mechanism underlies the fundamental structure of the universe, we might be able to sense what is happening in the farthest corners of the universe even before light reaches us. This idea suggests that data from the invisible regions of the universe can be transported not only through gravitational effects, but also through tunneling. When combined with quantum entanglement, the boundaries of tunneling expand even further. Perhaps one day, artificially created entangled particles in a laboratory environment could tunnel to the inaccessible corners of space, carrying information with them. Thus, humanity could obtain direct data about the most distant and darkest regions of the universe. This would completely eliminate the boundary that classical astronomy refers to as a line and transport our scientific imagination to entirely new dimensions. From the perspective of classical physics, such an observation is impossible because information cannot travel faster than light, and takes our scientific imagination to entirely new dimensions. From the perspective of classical physics, such an observation is impossible, as information cannot be transmitted faster than the speed of light, and the cosmic event horizon is the definitive boundary for information flow. However, quantum tunneling opens a window that challenges these dogmas. Perhaps tunneling and entanglement are the keys to new, as yet undiscovered communication channels in the depths of the space-time fabric. In other words, communicating with the invisible regions of the universe may one day cease to be a technical issue and become routine in quantum technology. For now, this remains a scientific hypothesis, but throughout history, the greatest breakthroughs have been the product of dreams that once seemed impossible. Perhaps thanks to tunneling, the map of the universe will one day be drawn not only by light, but also by invisible quantum passages. Then the concept of the unknown will cease to exist. Humanity will find the answers to every question about the universe in the secret paths of tunneling. 72. Could the combination of tunneling and light create new forms of communication? Light is the fastest carrier of information in the universe, but even so, as distances increase, delays and losses in communication are inevitable. However, quantum tunneling has the potential to create new forms of communication by shortening the path of light or merging with it to transcend classical boundaries, especially in fiber optic communication. While light signals follow a specific path, tunneling could enable some photons to jump through normally impassable regions, revolutionizing transmission. This could form the basis for lossless, ultra-fast new protocols in fiber optic networks and data transmission. Because tunneling transfers energy or information packets to the other side without physically overcoming classical optical barriers. Additionally, by combining light with quantum entanglement, instantaneous information transfer between different continents or even planets becomes technically feasible. While this technology is still in its infancy, initial experiments suggest that tunneling could lead to groundbreaking results in optical communication. Tunneling does not only offer speed advantages, but also revolutionizes security. In classical light-based communication, the risk of eavesdropping and interference always exists. However, quantum tunneling creates unbreakable communication channels that instantly detect external interference. In the future, both the speed and security of communication will be redefined in a way that cannot be reversed. This innovative form of communication could fundamentally affect not only human technology, but also the social, cultural, and scientific structure of humankind. One day, human interaction will be transported to a completely different dimension through the beyond light paths opened by tunneling, and the world will have transcended all boundaries in information sharing. 73. How can the tunneling phenomenon be observed in cosmic events? The effect of quantum tunneling can manifest itself not only in laboratory environments or technology, but also in the massive scale events of the universe. especially in high-energy astronomical events such as the death of stars, the birth of black holes, and supernova explosions. Tunneling occurring at the subatomic level leads to macroscopic results. For example, without tunneling in the core of a star, hydrogen nuclei could never fuse, and the star's energy production would never begin. A more striking example is Hawking radiation observed around black holes. Here, one of the virtual particle pairs created by quantum fluctuations can fall into the black hole, while the other tunnels out through the event horizon. This is a unique process that causes black holes to lose mass over time and eventually disappear completely. In other words, quantum tunneling acts like an invisible engine that determines the fate of the most mysterious and powerful objects in the universe. Traces of tunneling can also be detected in the process of cosmic rays reaching Earth, or in the sudden changes in the magnetic fields of neutron stars. Scientists are studying the tunneling mechanisms at work behind such massive cosmic events using space telescopes and ground-based detectors, striving to better understand both the structure of the universe and the scope of quantum laws. The observation of tunneling in cosmic events shows how decisive subatomic processes can be in the functioning of the universe. In other words, everything from galaxies to stars is shaped by an invisible quantum leap. Humanity's cosmic history is being written by the invisible touch of tunneling. 74. Can the flow of time be manipulated with quantum tunneling? Time is the most unchanging and inevitable reality in human perception. However, the effects of quantum tunneling on time are shaking this concept to its core. In some tunneling experiments, the time it takes for a particle to overcome an obstacle is much shorter than classical predictions and can sometimes occur instantly. In other words, the flow of time at the subatomic level is not a fixed, straight line, like in the macroscopic world. It is a field of possibilities filled with jumps, delays, and accelerations. These findings could open new doors for bending or accelerating the flow of time. If the tunneling process can be manipulated in the desired way, it might be technically possible to speed up time, or even skip it for certain events. In quantum computers, for example, the dramatic reduction in processing time compared to classical computers is a practical example of tunneling's effects on time. The manipulation of time is not only a groundbreaking claim technologically, but also philosophically. If we can control time jumps at the subatomic level, we could develop new technologies to influence the order and duration of events at the macro level. This could open up incredible opportunities for future time management, fast computing, and perhaps even slowing down aging. Of course, for now, this is a theoretical potential limited to the laboratory. But the history of science has shown time and again that what seems impossible today can become tomorrow's ordinary reality. Quantum tunneling's power to bend time could open the door to one of the greatest revolutions in human history. Could quantum tunneling enable new forms of life to emerge in space? The existence of life in the boundless and extreme conditions of space remains a mystery. However, the nature of quantum tunneling, which makes the seemingly impossible possible, could open the door to new forms of life, even in the most extreme environments of the universe. In particular, overcoming barriers between molecules through tunneling in environments where classical life is impossible, such as high radiation, low temperatures, or intense gravity, could create an unexpected acceleration in chemical evolution. In astrobiology, It is known that organisms called extremophiles can survive through molecular leaps beyond classical biochemistry. If quantum tunneling plays an active role in the genetic structure or metabolic pathways of these organisms, lifelike processes may have developed in nearly every corner of the universe, especially in interstellar ice, the moons of gas giants, or regions with intense cosmic radiation. Tunneling-based molecular reactions could give rise to new and unpredictable life forms. This scenario takes the search for life beyond Earth in a completely different direction. Life based on quantum mechanisms, which transcends the limits of classical biology, can exist without being bound to water and carbon-based chemistry. This gives rise to the idea of quantum ecosystems, which take the diversity of life in the universe beyond our imagination. Ultimately, quantum tunneling may be transforming not only the fundamental dynamics of physics and chemistry in the universe, but also those of biology. In the future, encountering strange and unique life forms emerging through tunneling in the far corners of the universe could mark the beginning of a new era for humanity. 76. Could quantum tunneling open the door to new laws of physics? All the laws that physics is based on today are actually based on patterns and repetitions in the macro world that we can observe. However, quantum tunneling is a phenomenon that challenges these laws, proving that they are not absolute and that entirely different mechanisms may exist at the core of nature. This is because the tunneling phenomenon transcends the boundaries of classical energy, motion, and causality. It demonstrates that there are no absolute barriers at the subatomic level and that the universe flows like a constantly rewritten script. It turns out that even the barriers that scientists call forbidden passages are, in a sense, only the limits of possibilities. This has two implications for physicists. First, the discovery of new rules beyond the laws we know today is no longer just a dream, but an experimental necessity. Second, thanks to tunneling, we're observing that some types of energy and matter move in ways that are completely contrary to classical physics. In particular, phenomena such as negative energy density, the reversal of the time arrow, and challenges to the speed of light suggest the existence of an entirely different physics seeping through the doors opened by tunneling. If tunneling can be manipulated on a macro scale, perhaps gravity, the bending of time and space, and even the relationship between matter and energy will be defined by entirely new rules. Thus, many phenomena we currently deem impossible could become tomorrow's ordinary reality. The unexpected behaviors of tunneling in particle accelerators, cosmic events, or superconducting circuits could signal the dawn of a new era of physics beyond current rules. The new window opened by quantum tunneling is reigniting science's greatest motivation, the desire to ask questions. It is prompting us not only to question how the universe works, but also why it works the way it does. The foundation of new physical laws may lie hidden behind these invisible passages in the chain of possibilities that tunneling enables. Can tunneling explain why the universe is so large and diverse? While we would expect the universe to consist of only a few fundamental laws and a limited number of particles, the reality we observe is incredibly diverse and vast. Every galaxy, star, planet, and even every living thing exists in a unique order that is not repeated anywhere else in the universe. Quantum tunneling could be the hidden architect of this diversity and magnitude, because in the subatomic world, every tunneling opens the door to a new possibility, a new chemical, a new star, or a completely different phenomenon. The unlimited options offered by tunneling enable new combinations, new orders, and unexpected forms to emerge in every corner of the universe at every moment. In this process, randomness and non-deterministic events play a critical role. Tunneling creates a complex chain of possibilities that redefines the future of the universe at every moment. The reason the universe is so large and diverse lies not in the uniform, repetitive nature of classical laws, but in the flexibility and diversity brought about by tunneling. In other words, the universe enriches itself spontaneously in the infinite game of possibilities offered by quantum tunneling. Furthermore, tunneling plays a critical role in the birth of elements, molecules, stars, and even galaxies. The existence of elements that sometimes seem impossible, exotic star types, or unusual galaxies may be the direct result of tunneling jumps at the subatomic level. In other words, the universe is transforming from something ordinary and uniform into a labyrinth that holds a different miracle in every corner. Ultimately, the vastness and diversity of the universe are shaped by the infinite possibilities created by tunneling. The architects of reality are the invisible leaps in the subatomic world, and everything exists within the universe of possibilities opened by tunneling. 78. How does tunneling push the boundaries of scientific knowledge? Science relies on observable, measurable, and repeatable phenomena. However, quantum tunneling, being a process that cannot be directly observed and only reveals itself through indirect effects, completely challenges the boundaries of knowledge in the classical sense. Because during tunneling, it is never possible to determine with absolute certainty where a particle is, how it moves, or when it transitions. We can only talk about probabilities and outcomes. In other words, we see that even what we call information bends and stretches in the quantum world. This situation shakes the certainty of classical knowledge. For scientists, tunneling is a journey to the edge of the unknown. In the subatomic world, absolute observation and definitive results become impossible. This heralds a new era in which knowledge is no longer based on absolute truths, but on the management of probabilities and uncertainties. Sometimes tunneling can only be understood through its results, which forces science to go beyond direct observation and rely more on theoretical modeling and indirect evidence. The new paradigm brought about by quantum tunneling is fundamentally changing the nature and methods of science. Many rules that were once accepted as scientific facts are now seen as merely valid approaches under certain conditions. This is because tunneling proves that even the universe itself lacks absolute certainty. Information flows through an infinite and ever-changing network. This new perspective is attracting the attention not only of physicists, but also of philosophers and philosophers of science. The unknowability revealed by tunneling both challenges the limits of knowledge and makes humanity's view of the universe more modest and creative. 79. How does tunneling break the classical principle of causality? At the heart of classical physics, every effect has a cause, and events follow each other in a definite sequence. However, quantum tunneling has such an unusual nature that it breaks this chain of causality. Because in tunneling, there is no absolute answer to the questions of why and how a particle appears on the other side of an obstacle. In other words, events are explained solely by probability. Seeking an absolute cause for something to be becomes meaningless. Causality gives way to the dominance of randomness and uncertainty. This shows that at the core of the universe, cause and effect relationships are merely an average. Tunneling does not provide a definitive explanation of whether a particle will be here or there, but only states with what probability it will appear in a given location. This shows that the rules of classical physics are only valid at certain scales and under specific conditions. In the subatomic world, all causality is entrusted to the random choices of probability waves. Philosophically, this revolutionizes our view of the universe, because the assumption that every event has a cause is no longer valid. Thanks to tunneling, reality becomes a network of phenomena that is constantly reborn in a sea of randomness and uncertainty. Causality remains a meaningful concept for human perception, but at the heart of the universe, tunneling breaks down and reshapes this concept. For scientists, this pushes the boundaries of explanation and prediction. Therefore, with the discovery of tunneling, physics has transformed into a completely different field of research that focuses not only on what will happen, but also on, is it possible, and with what probability? 80. What are the philosophical implications of quantum tunneling? Tunneling has not only scientific, but also profound philosophical implications. This is because in the classical world, reality is defined by clear lines and absolute rules. However, in the quantum world where tunneling reigns, nothing is absolute and unchanging. Here, reality is nothing more than a cloud of potentials vibrating on a matrix of probabilities. This leads humanity to question concepts such as right-wrong, existence, non-existence, and cause-effect. In philosophy, classic questions about the nature of reality, the certainty of knowledge, free will, and even the absoluteness of time and space take on new meaning with tunneling. This is because the uncertainty introduced by tunneling transforms reality from a singular and fixed structure into a constantly changing space filled with an infinite number of alternatives. In other words, when humans observe the universe, they are not merely observing a result, but rather choosing only one of an infinite number of possibilities. This sea of uncertainty and possibility also breathes new life into debates about free will and destiny. If reality at the subatomic level is shaped by random choices, could humans also have a say in their choices? Or are we, like an electron, merely living one of the infinite possibilities? The new philosophical picture revealed by tunneling shows that science will never be able to provide complete answers to humanity's big questions, because reality, like tunneling, is a mystery that is constantly being rewritten and can never be fully solved. For humanity, this will remain both a humble lesson and a source of creative inspiration. 81. Can quantum tunneling prove that reality is not fixed, but a constantly evolving process? The most radical claim of quantum tunneling is that reality is far from being static, fixed, or unchanging as we believe it to be. Every tunneling event that occurs at the subatomic scale reveals a model of the universe where reality is constantly being rewritten. In other words, whether a particle is here or there is not determined by an absolute law or certainty, but by a continuous choice made in a sea of possibilities. This can be imagined as if an invisible die is being rolled at every moment, and the next image of the universe is shaped according to the outcome of that roll. The fall of a stone, the explosion of a star, or a person taking a breath. Everything is a macro-world reflection of reality that is constantly being rebuilt at the quantum level. This perspective represents a fundamental paradigm shift, not only for theoretical physics, but for all sciences. In classical science, reality is a fixed whole, established through observation, measurement, and repetition. However, tunneling reveals that the structures we perceive as fixed are merely instantaneous selections from an infinite potential. The constant recreation of reality suggests that time, cause and effect relationships, and even our identities are not absolute and permanent, but rather momentary fluctuations. If every tunneling at the subatomic level is a mini Big Bang, then our entire universe is a vast process in which an infinite number of tunneling events occur side by side and on top of each other. When we apply this idea to everyday life, we can imagine that the universe we live in is not just a single script. It is an orchestra of possibilities, formed in the shadow of an infinite number of alternatives, where billions of invisible passages open and close every moment. For example, even the smallest decision a person makes in their life exists as a byproduct of billions of tunneling events in the subatomic world. The idea that our minds, feelings, and even our memories are snapshots based on constantly changing possibilities, such as quantum tunneling, can overturn our classical sense of identity. The continuity of reality is actually an illusion. What is real is a symphony of possibilities that is constantly being reconstructed. The fundamental question that arises here is this: if reality is not fixed but a constantly evolving process, then the meaning of the past and the future takes on a completely different form. While classical physics presents time as a linear line, tunneling and quantum probabilities may point to an infinite now, where everything is recreated at every moment. Ultimately, tunneling tells us that the only thing that is constant in the universe is infinite change itself. Even the stones we think of as solid are nothing more than a wave, frozen for a moment in the flow of infinite possibilities. 82. With the effect of tunneling, can multiple realities exist simultaneously at every moment in the universe? Quantum tunneling not only reduces the universe to a cloud of possibilities, it also presents a mind-boggling picture in which multiple realities can exist side by side and intertwined at the same time. In this approach, known as multiverse or many worlds, tunneling gives rise to a new branch of the universe each time. That is, in every tunneling event, all of the universe's possible pasts and futures take shape as separate realities. Even if the probability of a particle tunneling is only 1%, if that probability is realized in reality, the opposite is happening in another universe. Thus, billions of parallel realities emerge at every moment. This concept shatters our classical understanding of causality and a single timeline. Because tunneling does not lead to a single outcome, every possible path, every possible choice, and every possible transition finds life in another branch of the universe. As you read these lines, another you in another reality may be making a different decision, or the same particle may remain in its old place without tunneling at all. This gateway to multiple universes transforms physical reality into a machine that produces a new possibility in every frame, like an endless film reel. From a scientific perspective, the mathematical foundation of this idea is strong, but it cannot be directly observed. Nevertheless, double-slit experiments conducted in laboratory settings demonstrate that particles can exist on multiple paths simultaneously, and that each alternative outcome is mathematically considered real through tunneling. From a philosophical perspective, the human mind's focus on a single reality may also be a kind of narrowing of possibilities. Perhaps we are locked into only one of an infinite number of universes and realities. This immense multiplicity adds a new dimension to discussions of human freedom and destiny. If every choice leads to a different outcome in another universe, The concept of destiny is shattered. Humans are nothing more than travelers in an infinite web of possibilities. Tunneling shows that the universe is not static, but a constantly branching story. In this story, every tunneling opens a door to a new reality, and every decision opens a door to a new universe. 83. Could tunneling be connected to consciousness and free will? The human mind, free will, and consciousness are concepts that have been debated throughout history, but no definitive answer has ever been found. Quantum tunneling adds a whole new dimension to this debate. Because while classical brain models view all decisions as the result of chemical and electrical processes, quantum biology seriously considers the possibility of tunneling in neural structures, such as microtubules. If tunneling occurs in the smallest building blocks of the human brain's decision-making mechanisms, the concept of free will takes on a whole new meaning. Because in every synaptic transition, it is not just chemistry that is at play, but also probabilities and randomness. This implies that every human behavior, every thought, every feeling, and every choice is actually determined by a probability distribution. Perhaps when we think we are making a conscious decision, we are actually witnessing the realization of one of billions of tunneling possibilities. For example, even a simple yes-no decision is the result of thousands of random passages at the subatomic level. The statistical distribution of these tunneling events in certain regions of the brain may go beyond the idea that our decisions are predetermined and instead make them feel like genuine choices. Of course, no experiment has yet been conducted to directly prove this idea. However, scientists have obtained data suggesting that quantum tunneling is observed in living tissues, particularly in protein folding and neural transmission. It has also been proposed that what we call conscious experience is actually a kind of collapse of quantum superposition at the macro scale. In other words, at every moment, we collapse into only one of billions of possibilities, and consciousness is the experiential name for this transition. Philosophically, this picture requires us to re-examine the concepts of free will and responsibility. If our will arises from the randomness of tunneling, then the limits of our freedom and the nature of human behavior are redefined within infinite possibilities. Perhaps consciousness, like the universe itself, is a quantum leap that can never be fixed, but is constantly being rewritten. To be human is to be a conscious wave, playing the most complex and magnificent role of tunneling in the universe. 84. Is it possible that tunneling is a necessary mechanism for the emergence of life in the universe? The existence of life in the universe was long explained as the result of ordinary chemical processes. However, modern biochemistry, especially quantum biology, suggests that tunneling may have played an indispensable role in the emergence and evolution of life. This is because overcoming obstacles in the subatomic world is often impossible according to the laws of classical physics. But tunneling steps in precisely here, imparting speed and diversity to the first chemical reactions that made life possible. For elements in the universe to come together and form complex building blocks, such as new molecules, proteins, and DNA, subatomic passages must be crossed quickly and unexpectedly. Tunneling provides randomness and speed in these processes, revealing a picture where life is not a coincidence, but a necessity. In other words, without quantum tunneling, the universe could have remained a static, lifeless pile of atoms for billions of years. However, thanks to the unimpeded passage provided by tunneling, millions of molecules form new structures every moment, and biological diversity and evolution continue to accelerate. Astrobiology research suggests that tunneling-based chemical reactions could occur even under the most extreme conditions in space. This implies that life is not a miracle unique to Earth, but a process that is possible in nearly every corner of the universe. The role of tunneling in the formation of the first living cells on our planet may be far greater than we imagine. If life is an inevitable consequence of tunneling, then our existence in the universe will be almost impossible. In every star system, in every corner of every galaxy, life could be constantly reborn through the chemical pathways opened by tunneling. The existence of life in the universe appears to be a natural consequence of the cosmic necessity of quantum tunneling. 85. Could tunneling create a hidden communication network in the unknown background of the universe? Quantum tunneling may not only enable particles to overcome obstacles, but may also point to the existence of an invisible communication network operating continuously in the deepest layers of the universe. At the subatomic level, each tunneling event is not limited to the movement of a single particle. It can also trigger a chain reaction that affects the entire space-time fabric around it. This chain connects all matter and energy in the universe, like a vast network that we cannot see, but whose effects we can feel. Within the framework of modern physics known as quantum field theory, the fabric of the universe seems to ripple with the vibrations of an infinite number of tunneling possibilities. Each particle, as a node in this network, instantly influences both its own destiny and the state of the entire universe. This network of possibilities is not a cable or signal transmission in the classical sense. Thanks to tunneling, the location of a particle can instantly affect particles billions of kilometers away through entangled particles. Here, quantum entanglement, known as spooky action at a distance, intertwines with tunneling, giving rise to a kind of sea of information that envelops the entire universe. In laboratory experiments, it has been demonstrated that entangled photons can instantly influence each other independently of classical signals. If these events are a cosmic reflection of tunneling, every corner of space could be connected by an invisible form of communication. This idea suggests that the universe is not only visible but also active through its background energy, constantly redistributing information. Some scientists believe that unknown cosmic phenomena, such as dark matter and dark energy, could also be explained by the influence of this quantum communication network. On the vast scale of the universe, it may not be the rules of classical physics that govern, but rather the probability networks created by tunneling and entanglement. In such a network, the transfer of information and energy could occur much faster, more directly, and without obstacles than we imagine. Ultimately, the idea that the phenomenon of tunneling forms a kind of cosmic nervous system in the unknown background of the universe is fascinating, both scientifically and philosophically. Every event in the universe may create an echo that resonates not only at its point of origin, but throughout the fabric of the cosmos. In other words, the universe exists as a system integrated by an invisible but indispensable quantum communication network, from the subatomic level to the galactic scale. Perhaps one day, when we develop a technology that allows us to listen to this network, we will truly be on the verge of unlocking the universe's deepest secrets. 86. Can tunneling create real-time parallel consciousness in the human brain? Traditional neuroscience explains the functioning of the brain through electrical signals and chemical transmissions. However, recent findings in quantum biology suggest that tunneling takes the brain's information processing capacity far beyond classical models. Tunneling events occurring in microtubules, the molecular structures within neurons, allow signals to jump almost instantaneously and randomly. This suggests that consciousness is not formed through a sequential flow like a classical serial processor, but rather like a parallel processor, processing multiple different possibilities simultaneously. This idea defines human consciousness not merely as the sum of past experiences or a chain of chemical reactions, but as a vast quantum superposition where, at every moment, billions of different possibilities overlap, and one of them momentarily emerges as reality. The simultaneous occurrence of tunneling in different regions of the brain allows a person to experience transitions between different thoughts, emotions, and images at the same time. Perhaps dreaming, sudden inspiration, creativity, or complex intuitions are products of the brain's parallel consciousness states. In some laboratory experiments, it has been found that interneuronal communication occurs at speeds and in ways that cannot be explained by classical models. Such observations suggest that the brain's information processing capacity is too complex to be explained by chemical transmission alone. Quantum tunneling may be functioning like hidden highways, connecting neural networks, giving the human mind unlimited combinations and speed. If tunneling plays a critical role in the basic functioning of the brain, then human consciousness and memory exist instantaneously by selecting only one of infinite possibilities at any given moment. This completely changes the foundations of free will, consciousness, and the concept of self. Human creativity may be hidden in the parallel paths of consciousness opened up by tunneling. One day, when we solve this mechanism, we may not only unlock the secrets of the human mind, but also reach entirely new levels of consciousness. 87. Could quantum tunneling pave the way for new technological revolutions that transcend the boundaries of physical reality? The no-barrier property of quantum tunneling at the subatomic level is paving the way for leaps in technology that were previously unimaginable. All of the computers, sensors, medical devices, and energy storage systems we use today operate thanks to the speed and efficiency provided by tunneling. However, the real revolution will begin when this mechanism is fully understood and can be manipulated. This is because the randomness and superposition underlying tunneling create unlimited new possibilities in information processing, communication, energy production, and even biotechnology. Quantum computers have the capacity to solve problems that classical computers would take hundreds of thousands of years to solve in just seconds. The secret behind this lies in tunneling's ability to evaluate alternative paths simultaneously and find the shortest solution. In other words, information can reach its destination directly by jumping through quantum gates without following classical paths. In the future, this technology will transform every aspect of life, from artificial intelligence to genetic engineering, medicine, and energy networks. Another revolution is emerging in the applications of tunneling in energy and materials science. From superconductivity to atomic-scale manufacturing, many innovations are a direct result of tunneling. While nanoscale machines cannot transport atoms or molecules using classical methods, tunneling allows them to go beyond physical limits, making previously impossible material combinations possible. This opens the door to countless revolutions, from next-generation batteries to nearly lossless energy transmission and molecular computers. The nature of quantum tunneling, which bends the absolute laws of physics, demonstrates that all technological barriers are merely temporary and surmountable. Every new discovery reflects humanity's desire to challenge nature through technology. Perhaps in the near future, a completely new civilization will emerge, transcending the physical world through the limitless gateways offered by tunneling. 88. Could quantum tunneling be a leap forward for humanity? Throughout history, humanity has experienced leap-forward moments with new discoveries or technological revolutions. The discovery of fire, the invention of writing, the discovery of electricity, the spread of the internet. Tunneling, however, could be the universal and invisible revolutionary force underlying these leap moments. Because every tunneling event occurring at the smallest building blocks of the universe leads to immense consequences, not only in the micro world, but also at the macro level. Perhaps humanity will open a brand new era in its history through the full understanding and integration of tunneling into daily life. Imagine a world where the randomness and possibilities offered by tunneling can be consciously managed. Technological and social progress would take on a whole new speed and diversity. For example, an energy source that is impossible to access through conventional means could suddenly become available through tunneling. Or it might be possible to produce drugs that can overcome obstacles at the subatomic level to treat diseases. Even in terms of access to information and intelligence, the alternative paths opened up by tunneling could fundamentally change the human brain and the way we learn. This leap is not merely technological. Humanity's understanding of itself, the universe, and reality would also be fundamentally altered. Information accessible to everyone could spread instantly across the globe, and communication and collaboration could become instantaneous. Perhaps with tunneling-based technologies, it might even be possible to find swift and effective solutions to humanity's global challenges. The revolutionary leaps offered by tunneling in areas such as quality of life, health, education, and transportation on Earth will change the course of human history in a way that can never be reversed. Quantum tunneling may be the beginning of an era in human history that has not yet been written. Just as fire, electricity, and the internet were turning points for humanity in the past, the doors opened by tunneling may herald the transition to a new era of humanity. In this era, boundaries will be transcended not only physically, but also mentally and socially. And perhaps the real great leap forward awaits us in invisible quantum gateways. 89. Could tunneling support the idea of a universal memory? The concept of universal memory, or cosmic records, which is often discussed in scientific and philosophical circles, is based on the idea that every event in the universe is somehow recorded, never erased, and stored in another plane. Classical physics cannot provide a mechanism to support this. However, quantum tunneling and entanglement create an infrastructure where the effect of every event can be instantly transported to another corner of space. Through tunneling, it is theoretically possible for the trace of everything that happens in the universe to be stored as quantum information. This perspective supports the idea of a universe in which every particle movement, every energy transfer, and every wave collapse is recorded in a universal memory. In other words, nothing that has ever happened in the past is completely lost. It all continues to exist as traces in the quantum fabric of the universe. Some scientists suggest that black holes do not swallow information, but rather distribute it to other parts of the universe through entangled and tunneling particles. This brings together Hawking's information paradox and cosmic memory theories. Philosophically, this adds a new dimension to the concepts of consciousness, destiny, and identity. It is conceivable that the human mind, or the collective unconscious, is in a constant exchange of information with the universe at the quantum level. Dreams, intuitions, or sudden déjà vu experiences may be macro-level reflections of microscopic information flows leaking from this universal memory. The phenomenon of tunneling, which keeps the universe's memory alive and in a constant flow, carries both scientific and mystical meaning. In the future, the complete understanding of this field could radically change the ways we access information about the past, the present, and even possible futures. Behind quantum gateways, perhaps the entire story of the universe is hidden. 90. Could quantum tunneling offer new opportunities for humans to transcend themselves? Since the dawn of humanity, humans have had a desire to push their limits, transcend themselves, and achieve the impossible. At times it has challenged nature, at times technology, and at times its own mind. Quantum tunneling, however, could be the direct physical counterpart to this ancient desire. Because tunneling proves that even the most rigid physical barriers are surmountable, and that there is no such thing as an insurmountable obstacle, not even at the fundamental level of the universe. This perspective is a profound source of inspiration for human psychology and personal development. When we realize that the difficulties we encounter in life are often merely a matter of perspective and a chain of possibilities, we redefine our limits. If a subatomic particle can tunnel through a barrier that it theoretically cannot pass, then the human mind and will can also find new ways to overcome its own obstacles. Here we arrive at a point where the philosophy of personal development and scientific reality shake hands. It can be argued that quantum tunneling can create leap moments, not only in the physical universe, but also in the social and psychological realms. Transforming habits, learning patterns, and even levels of consciousness by tunneling can mean expanding one's potential in an unlimited way. When humans embrace the essence of randomness and leaps at the subatomic level, they accept that change is a natural and inevitable part of life, rather than something to fear. Perhaps the true human revolution lies in the freedom offered by tunneling. In a limitless universe, humans can constantly transcend their own mental and emotional boundaries. True potential lies hidden in the universe of possibilities, and as tunneling whispers to us, every obstacle exists to be overcome. Could quantum tunneling form the theoretical basis for time travel? Time travel is one of humanity's oldest dreams. but until now it has remained the stuff of science fiction. However, quantum tunneling encourages us to imagine time not as a linear one-way river, but as a network of possibilities where infinite possibilities and leaps occur. Because in the subatomic world, a particle can overcome obstacles not only in space, but also potentially in time. In tunneling, a particle's leap from now to the future, or theoretically, the past, may seem impossible in the classical sense, but the concepts of time symmetry and reversibility in quantum physics imply that reality is much more flexible. Especially in Feynman's diagrams, it has been shown that some particles reflect back in time, and it has been suggested that tunneling could be the fundamental mechanism enabling this process. If tunneling occurs not only in space but also in time, it means we are not bound by the linear flow of time. In this case, under certain conditions, a particle could theoretically send a signal to the past, or a future event could influence the present. In some quantum experiments, the decision to measure has appeared to alter a past possibility. This has reignited debates about whether the flow of time can be reversed or restructured through tunneling. Scientists still caution that this does not directly imply time travel. However, they acknowledge that physical laws are not absolute and that time can be bent at the quantum level. The idea of time travel has captivated not only physicists, but also philosophers and artists. It implies that a choice made in the past is not permanently closed, that each tunneling opens a new branch of time, and that human life and history exist within a labyrinth of possibilities. If one day it becomes possible to manipulate the time axis through tunneling, humanity will establish a completely new relationship with its past, future, and present. The flow of life and the sequence of events will no longer be a single predetermined path, but a cosmic symphony of endless alternatives flowing side by side. For now, time travel remains a possibility beyond laboratories and mathematical equations. However, the potential of tunneling to open passages through time continues to be one of humanity's most radical quests to understand the universe. Perhaps one day time travel will become part of everyday life as one of the byproducts of tunneling. And when that happens, the meaning of the past, present, and future will be fundamentally altered. 92. Can quantum tunneling delay the death of the universe? The ultimate fate of the universe is predicted in classical cosmology to end with a heat death, or complete disintegration and the attainment of maximum entropy. However, quantum tunneling presents a profound paradox that suggests even this absolute end may be an overcomable obstacle. This is because everything in the universe is constantly overcoming obstacles at the subatomic level to leap into new states. This process may be continuously delaying the universe's arrival at an absolute end. Just as tunneling enables energy production in stellar cores, it could create pathways that allow new processes to begin on a cosmic scale. The evaporation of black holes through Hawking radiation, supernova explosions, and even virtual particle pairs emerging in the voids between galaxies are all explained by the effect of tunneling. Even if the universe is approaching an end, probability gateways in the subatomic world could open new pathways for energy and matter. Some even suggest that quantum tunneling could serve as a cosmic scale mechanism for a great rebirth or a transition to another universe. In other words, the death of the universe may not be an absolute end, but rather the gateway to a new beginning, thanks to tunneling. Theoretically, the total energy and mass balance of the universe, including dark energy and matter, may be constantly being restructured by tunneling events. This could mean that the fate of the universe is not an absolute cold end, but rather a continuous cycle of renewal and change through successive new tunneling passages. This idea, known as the quantum cosmic cycle, is akin to the physical translation of infinity and rebirth. In conclusion, even if tunneling cannot indefinitely postpone the universe's death, it may open the doors to new births, new possibilities, and perhaps even new universes at what we consider to be the end of the universe. Like life itself, the universe may be constantly re-emerging through the invisible hands of tunneling. The fate of the cosmos may be written in the infinite passages of tunneling. 93. Does tunneling completely invalidate the concept of coincidence? In our daily lives, we often explain events as coincidence or chance. But in the reality of the subatomic world, where tunneling reigns supreme, randomness and uncertainty become the fundamental dynamics of the universe. In tunneling, whether a particle will overcome an obstacle or not is not 100% predictable. It can only be estimated through probability calculations. This means that every event does not have a predetermined cause, and the universe is constantly in a state of randomness and probability. In other words, what we perceive as coincidence is actually an inevitable part of the fundamental workings of the universe. This perspective fundamentally changes our perception of the universe and our own lives. Because what we call chance or luck are not randomness in the classical sense, but the macro-world manifestations of billions of tunneling events occurring at the quantum level. The direction in which a stone falls in the air, when an electron will overcome an obstacle, or the unexpected encounters in a person's life, all of these emerge as inevitable coincidences in the matrix of possibilities created by tunneling. 96. Could tunneling shed new light on the concept of conscious matter in the universe? Consciousness and matter were seen as two completely separate domains in classical science. However, quantum tunneling presents a new picture where matter and consciousness are inextricably intertwined at the subatomic level. Because tunneling is not merely about matter overcoming obstacles, but also about a constant flow of awareness between information, probability, and potential. If there is a continuous dialogue between matter, information, and possibility at the subatomic level through tunneling, this process may underlie conscious experience. Modern quantum biology research suggests that conscious experiences may be hidden, not only in neural circuits but also in tunneling events occurring at the microscopic level. If matter is not independent of consciousness, then every atom, every molecule, every biological structure in the universe may possess a form of awareness. This paints a picture that is philosophically close to panpsychism, the view that everything in the universe is conscious to some degree. Scientifically, it is not yet clear how tunneling could provide a concrete basis for the idea of conscious matter. However, laboratory experiments have shown that some biomolecules exhibit reactions that are too fast and effective to be explained by classical chemistry, and that these processes are linked to tunneling. The possibility that tunneling phenomena occurring in the brain and living cells could form the biophysical basis of consciousness invites us to rethink humanity and the universe. In this case, the biggest question for humanity would be, is consciousness a phenomenon unique to the brain, or is it a property of the most fundamental building blocks of the universe, distributed as a stream of awareness in the subatomic world? Whatever the answer, quantum tunneling will remain at the center of debates about the origin of consciousness and matter. 97. Does quantum tunneling enable us to understand humanity's cosmic origin? The origin of the universe has been one of humanity's greatest mysteries. Quantum tunneling, however, can be considered the fundamental mechanism behind the transition from nothingness to existence at the beginning of the universe. Because before the Big Bang, when there were no physical laws, no time, and no space, tunneling may have created a first leap in the subatomic ocean of possibilities, bringing our universe into existence. Thus, the birth of the cosmos is not merely a physical event, but a huge choice made among possibilities. While attempting to mathematically model the role of tunneling at the beginning of our universe, cosmologists emphasize that humanity's existence is also a byproduct of this enormous leap. We are beings that emerged on the accidental branch of the universe, one of the infinite possibilities created by tunneling. In other words, who we are, which galaxy and planet we inhabit, and even what elements we are made of, are the result of a series of random leaps in the subatomic world. Philosophically, this perspective makes humanity's place in the universe both more humble and more fascinating. We are not merely observers of the universe, but exist as a tunneling product within its network of possibilities. Our cosmic origins are the result of a miracle shaped by randomness and leaps in the subatomic world. Perhaps one day, when we fully understand the role of tunneling in the origin of the universe, we will also find a definitive answer to the question of where humanity truly comes from. And perhaps this answer will open the door to life and consciousness in every corner of the universe. 98. Could tunneling be the missing link in the grand unified theory? In physics, when we talk about the grand unified theory, or theory of everything, we imagine a single fundamental equation that explains all the forces in the universe: gravity, electromagnetism, strong and weak nuclear forces. To date, from Einstein to Hawking, and from Schrödinger to Feynman, many great minds have sought this unifying formula. But the laws governing the smallest and largest scales remain unconnected. Quantum mechanics and general relativity offer two fundamentally opposing descriptions of nature, one based on probability and randomness, the other on certainty and continuous flow. It is precisely here that the role of quantum tunneling brings the possibility of a missing link to the fore. Because tunneling may not only allow particles to overcome obstacles, but also imply invisible passages between the fundamental forces of the universe. In the subatomic world, phenomena such as particles jumping from one force to another, tunneling into another physical field, or virtual particles appearing and disappearing in the vacuum, are based on the underlying dynamics of tunneling. Quantum field theory, in which each particle is defined as a vibration of a field, suggests that tunneling could open new avenues at the limits of physical laws. For example, there are theories that tunneling-based, extremely rare transitions play a role behind processes that are still unobservable, such as proton decay. An even more striking dimension is that tunneling may function not only at the microscale, but also at the cosmic scale as interdimensional passage. According to some cosmological models, the vacuum in which our universe exists could tunnel into another vacuum. If these transitions triggered the birth of new universes as a result of the Big Bang, tunneling would become a cosmic key that unites not only physical forces, but universes themselves. Thus, a grand unified theory could only become possible through these multi-layered, multi-scale passages of tunneling. The unpredictable yet statistically certain, forbidden transitions of tunneling are being observed. Theoretical physicists are exploring the idea that tunneling could bend absolute barriers and introduce new forces or hidden dimensions, thereby explaining many symmetry breaks in mathematics that remain unexplained. Tunneling, which bridges classical physics and quantum mechanics in the subatomic world, could also serve as a portal connecting general relativity and quantum mechanics in the macrocosm, and perhaps one day, the ultimate equation that explains all of nature's laws will be hidden in the mathematics of tunneling. In light of all this, tunneling is not just an exotic quantum phenomenon, but perhaps the most fundamental and comprehensive law of the universe itself. The key to a unified theory may be that infinite and continuous quantum gateway that stretches the boundaries of the macro and micro worlds, builds invisible bridges between all forces, and rewrites reality from start to finish. In physics, the essence of everything may gain meaning through tunneling itself. The theory of everything may actually be the gateway to everything. Could tunneling strengthen the scientific basis for the simulation possibility of the universe? The debate over whether the universe is a simulation has become a topic that has been seriously discussed not only by philosophers and popular science writers in recent years, but also by quantum physicists. Could tunneling be one of the fundamental arguments that compels us to take this debate seriously at a scientific level? Actually, yes, because the nature of quantum tunneling suggests that reality is not based on a continuous flow, but rather on a discrete and probabilistic calculation. The fact that every obstacle in the subatomic world is somehow instantaneously and irrationally overcome could indicate that the physical universe is composed of digital or discrete building blocks like computer code. According to simulation theory, the universe is not fundamentally continuous, but rather consists of a pixel-like structure or information matrix. In quantum tunneling, the continuous and deterministic behavior of classical physics is completely broken. Particles never pass through a barrier halfway. They suddenly appear on one side or the other. This digital switching bears a striking resemblance to the digital world of computers, which consists of ones and zeros. Additionally, the fact that all possibilities in the universe can be expressed as a mathematical wave function and collapse into a single outcome at the moment of observation or interaction offers a mechanism very similar to if-then commands, decision trees, or algorithmic randomness in software code. Tunneling, especially in complex systems, with its unexpected jumps and sudden resolution of superposition states, gives the impression that reality is being calculated or processed in the background of the universe. The fact that quantum probabilities measured in laboratory experiments exhibit behavior similar to algorithms that can be theoretically expressed in code raises the question of whether there is another layer of logic or software underneath reality. Some scientists even claim that Planck length and quantum energy levels could be a resolution of information, representing the pixel size of a simulation, much like the resolution of a screen. Taking this further, tunneling and other quantum phenomena could be argued to function not just as physical processes, but as shortcuts within the simulated reality. In other words, tunneling in the universe could be a way to bypass the limits of the simulation, much like a character passing through a wall or triggering a cheat code in a computer game. If there is an information processing process underlying the universe, tunneling could function as a direct intervention or computational accelerator of this algorithm. In conclusion, the phenomenon of tunneling is one of the strongest scientific indicators that the universe is not continuous, smooth, and deterministic. The digital, jumpy, random, and selective structure behind the universe, tunneling itself, plays a key role in taking simulation theory seriously. Perhaps one day, when we are able to decipher the code of reality, we will witness that tunneling is actually a programmer intervention or system update. At that point, the simulation debate will no longer be a philosophical question, but a physical reality in our lives. 100. How does tunneling affect humanity's questioning of its universal purpose? Quantum tunneling not only overturns physical laws and scientific techniques, it also brings a radical new perspective to humanity's purpose, search for meaning, and relationship with the universe. This is because tunneling is based on a model of reality in which nothing in the universe is absolute and fixed forever. Everything is formed in a flow of infinite possibilities, randomness, and instantaneous choices. This perspective also fundamentally shakes the search for a necessary meaning in oneself, one's life, and society. If everything is dependent on possibilities and random tunneling jumps, then our lives, choices, and values may not have a unique and predetermined purpose. This may seem like a disturbing, even chaotic, idea of the universe to some people. However, the cosmic freedom provided by tunneling, the idea that every moment is a new passage and every obstacle is surmountable, also offers humanity a genuine space for responsibility and creativity. The obstacles, opportunities, and paths that appear in our lives, like the quantum leaps in the subatomic world of tunneling, opening doors to new choices and possibilities for us. The universal purpose of humanity is to constantly transcend boundaries, create new meanings, stretch the limits of the existing, and explore the unknown, just as tunneling does in the universe. The greatest gift of tunneling is that it reminds us that change and transformation are not only possible, but inevitable. Life itself is not a static chain of destiny. It is an adventure that is constantly being rewritten in an infinite matrix of possibilities. Rather than waiting for meaning to come from outside, humans, like quantum particles, tunnel through their own obstacles and recreate their own stories at every moment. Our universal purpose is to recognize the obstacles before us, find new ways to overcome them, and build our own meaning in this game of infinite possibilities. Ultimately, tunneling teaches us that no path is blocked forever. Every obstacle holds a new reality, a new meaning, and a new life. To be human is to be a conscious and creative traveler in the infinite quantum passages of the universe. Our purpose in existence lies in choosing our own path, our own passage, our own story among these infinite possibilities. 101. Could quantum tunneling indicate that the universe is in a constant cycle of rebirth? Quantum tunneling shows that, by its very nature, no physical obstacle or barrier is absolute and eternal, that everything can be overcome one day, and that passages that seem impossible eventually open up over time. On a cosmological scale, this suggests that the universe is not a system doomed to be born and die only once, but that it can continue to exist through continuous rebirth cycles. After the Big Bang, The flow of energy, matter, and information that emerged in the universe can constantly reconstruct itself thanks to quantum tunneling. Each tunneling event creates a new starting potential in the depths of the universe. These constant leaps in the subatomic world play a critical role in the emergence of galaxies, stars, and life at the macro level. Some cosmological theories suggest that our universe could leap to a completely different energy level through a process called vacuum tunneling, triggering the birth of another universe. Here, tunneling refers not only to the overcoming of an obstacle by microscopic particles, but also to the very fabric of space-time itself, marking the beginning of a new cosmic order. Even the universe's progression toward absolute ends, such as heat death or the Big Rip, could sow the seeds of a new universe through tunneling. In other words, no finality in cosmic history is a true end. Every ending transforms into a new door to existence opened by tunneling. This cyclical reality has a profound impact not only on the structure of the physical universe but also on the nature of life and consciousness. In a universe where everything can exist again and again, in an infinite network of possibilities, even death is not a permanent closure, but a leap into another possibility, a new beginning. The crises, losses, and closures we experience in our own lives can be thought of as macro-scale reflections of this infinite renewal at the quantum level. Ultimately, quantum tunneling makes possible not only the beginning of the universe but also an infinite number of new beginnings. The cosmos, in the invisible hands of tunneling, vibrates like a sea of potentials, constantly being reborn. This cycle is the deepest source of the universe's infinite vitality and change. Everything is the story of constant tunneling and infinite rebirth. 102. Can the multiverse gateways, opened by tunneling, explain why there is so much diversity in our universe? The diversity in our universe, a dazzling richness ranging from galaxies to stars, living beings to elements, has been a mystery that has baffled scientists for centuries. While classical physics suggests that this diversity is largely due to random events and deterministic processes, quantum tunneling offers a completely different perspective. Each tunneling event does not merely overcome the existing obstacle, it also creates new possibilities and new branches. According to the multiverse theory, during tunneling, the universe splits into new branches, where every possibility becomes reality, and each branch may have different physical laws, elements, and forms of life. These portals enable an immense diversity to emerge in the fundamental building blocks of the universe. Every subatomic leap leads to different outcomes, not only in our universe but also in parallel universes. Thus, tunneling triggers the continuous branching of a cosmic tree of possibilities. As a result, unique chemical, physical, and biological combinations emerge in every corner of the universe. Everything from the life cycles of stars to the evolution of living organisms is a result of this endless branching, the new gateways opened by tunneling. The idea of a multiverse is not merely speculation. Some quantum experiments conducted in laboratory settings have demonstrated that particles can exist on multiple paths simultaneously and transition between possibilities through tunneling. These experimental data provide clues that a similar parallelism may exist at the cosmic level. The diversity in our universe is not only a result of physical laws, but also of the infinite possibilities opened up by tunneling. This perspective redefines humanity's place and freedom in the universe. In a reality where everything is not bound by a single destiny or fate, but where new passages and new paths open up at every moment. Humanity's search for meaning and creative power also expands infinitely. The multiple universe gateways of tunneling usher in a new era as the source of diversity in both science and philosophy. A quick reminder, if you would like to support me, you can click on the Join button at the bottom of the screen. Your support is truly valuable to me. Thank you in advance. Let's continue with our video. 103. Could quantum tunneling play a key role in explaining the true structure of the universe through the concept of the space of possibilities? The space of possibilities is often seen as an abstraction in physics and philosophy. However, quantum tunneling shows that this concept is an active force in the very fabric of the universe. At the subatomic level, every particle has the potential to exist simultaneously in all possible positions and energy states, not just in a single position or energy level. Each tunneling event represents the selection of one of these infinite possibilities as reality. This perspective reveals that the universe is not a precise and predetermined structure that functions like a machine, but rather a flexible and constantly renewing system in which possibilities are redefined at every moment. At every moment in the universe, infinite possibilities intermingle through the passages opened by tunneling. Some are selected, while others continue to exist as potential. When we accept that the space of possibilities operates in this way, it becomes clear that reality does not have a single correct answer or a single absolute path. Every subatomic jump, every tunneling, can create a small but fundamental change in the fate of the universe. This situation destroys the classical principle of causality and the understanding of a deterministic universe. Human behavior, major disasters in nature, the birth and death of stars, and even the formation of galaxies are determined by the sea of possibilities created by tunneling. In short, the true structure of the universe is a process where the space of possibilities flows constantly, dynamically, and boundlessly. The perspective opened up by tunneling has a transformative effect not only on scientists, but also on artists, philosophers, and even everyone who makes decisions in their daily lives. Because it shows that life does not have one single path, but that infinite passages, opportunities, and new beginnings are possible at every moment. The human mind also constantly discovers new paths in this universe of possibilities through intuition, creativity, and imagination. The deep relationship that tunneling establishes with the concept of the space of possibilities takes human freedom and responsibility to a broader horizon than ever before. Ultimately, to understand the true nature of the universe, we must abandon the classical understanding of fixity and singularity. Thanks to quantum tunneling, the space of possibilities ceases to be merely an abstract mathematical concept. It becomes the fundamental reality that weaves, renews, and creates the universe itself. This great leap brings about a revolutionary change in humanity's perception of the universe and its place within it. 104. Can tunneling fundamentally transform the classical cause and effect chain? In classical physics, the cause and effect chain is absolute and unchanging. Every event has a cause, every effect has a result, and this chain is never broken. However, quantum tunneling shakes this traditional thinking to its core. Transitions that occur through tunneling at the subatomic level do not have a cause and effect relationship in the classical sense, because it is impossible to determine in advance when and how a particle will overcome an obstacle. Probability and randomness become an integral part of the process in every transition. Thus, At the core of the universe, the classical cause and effect chain is replaced by a structure that constantly branches out, renews itself, and is guided by random choices. This paradigm shift has a radical impact not only on physical theory, but also on our understanding of humanity's place in the universe. The idea that an event is inevitable disappears. At any moment, a new path can open up, and every end can become a new beginning. With the effect of tunneling, all processes in the universe cease to be certain and inevitable and become open to possibilities and constantly renewing. In such a universe, human freedom is also taken to a whole new level, because our choices are no longer the product of a predetermined fate, but of a scenario that is constantly being rewritten within the space of possibilities. This change also leads to new approaches in scientific methods. Physicists no longer try to explain a single outcome, but instead focus on understanding all possibilities, statistics, and randomness. Quantum concepts such as the principle of uncertainty, superposition, and probability waves reveal that the universe has a much more flexible and creative structure beyond classical causality. The human brain, social order, natural events, everything takes shape in unpredictable ways in this sea of randomness opened up by tunneling. In conclusion, quantum tunneling does not merely bend the classical chain of cause and effect. It introduces an entirely new logic of probability. The true workings of the universe are an unpredictable but immensely creative process in which one of an infinite number of options is chosen at every moment. And this creative randomness allows everything in the universe to exist in infinite variety and innovation. 105. Could quantum tunneling demonstrate that there is a principle of creativity at the heart of the universe? Classical science long described the universe as a clockwork mechanism, governed by rigid rules and resistant to change. However, quantum tunneling reveals that the universe is driven by an endless creativity, constant improvisation, and a dynamism that gives rise to new possibilities at every moment. In the subatomic world, no process is absolute. No barrier is permanently closed to a particle. The leaps offered by tunneling, the ability of a particle to randomly overcome impossible barriers, suggest that at the heart of the universe there is not only repetition and necessity, but also a kind of cosmic freedom and creativity. This perspective provides a powerful foundation for likening the universe to an artist who creates new works at every moment, rather than a machine. This creative principle does not remain confined to the subatomic world. It manifests itself at the macro level as well. The birth of stars, the formation of new elements, the emergence of complex molecules, and ultimately, life itself. All are outcomes of the unexpected tunneling leaps at the subatomic level. The diversity in nature, the infinite variations in living beings, and social and cultural innovations. All are macro-level reflections of the universe's creative nature, which opens up new paths every moment. Nothing is fixed, repetitive, or predetermined forever. Tunneling implies that something new is possible at every moment, that the universe is constantly renewing itself, and that even the laws of nature are not fixed and unchanging. Throughout history, humanity has often attributed its creative breakthroughs, new discoveries, and great leaps in art and science to inspiration and chance. However, tunneling may suggest that this inspiration and creativity are not unique to the human mind, but that the universe itself is fundamentally driven by an infinite potential for improvisation and innovation. Consciousness, intelligence, and creativity may be the most sophisticated forms that this infinite freedom and leap capacity at the subatomic level of the universe takes in the human mind. The revelation of the principle of creativity in the universe through tunneling also legitimizes the human imagination, the desire to discover, and the power to transform. Reading Quantum Tunneling as a Principle of Creativity offers a perspective that brings together science, philosophy, and art. Everything in the universe is the product of infinite possibilities, random choices, and constantly renewing paths. This cosmic creative force also sheds light on human life and the search for meaning. Nothing is completely predetermined. Every moment holds the possibility of a new path, a new meaning. Quantum tunneling is both the fundamental law of the universe and its greatest source of inspiration. Share your thoughts with us, because discovering the unknown together is always more exciting. As Carl Sagan said, reality is stranger than we imagine. Science is the most powerful tool we have to understand that strangeness.